PLC, right? Yeah, you can choose that. Trainer is on the way, Mr. Tivian. Yeah, he's on the way right now. I'm the manager. My name is Swaran. So yeah, this is considered the first time we are conducting training in PLC, in Panasonic PLC specifically. But normally we specialize in Siemens, Bradley, Mitsubishi, Omron, Siemens. The less demanding one of the Siemens, Schneider, G, Fanuc, and even HRDCorp PLC lah. So, but Siemens most of the time we conduct training in Siemens. So, it's here already. Okay, so I will just give a quick introduction and then I'll be going on. I will print the Panasonic PLC manual that we just yesterday only we managed to prepare. The soft copy is right over here. So you can grab that and later I will print and pass it to you there. Okay, so that's our company introduction. The pen is complimentary. If you want a water bottle, so sweets out right over there, and so what is it? Black coffee, tea, coffee. I have prepared over there, all 3 in 1. Even hot water I prepared already. You can grab it. DIY glass hole I prepared already. Bring it over here. Just make sure to accidentally spill it. Okay, correct. So yeah, your name is Ajay. Ajay. Okay. So yeah, so I'll just give a quick introduction. Okay, so we have 2 company names. One is the Automation Services, another one is the Automation System Training Centre PLT. My boss, Mr. Sundaresan, his background, he was an ex-army technician. He was an ex-army technician and he majored in instrumentation. He was under DUTM, under the Air Force. And after he completed his service, he was from Kedah. Then he came down there in the 90s. He's now considered retired. He's 75, so he took over his place due to his health condition. Not training ready anymore. So after that, in 90s, when he came down here, at that time Singapore was booming. We looked for jobs in Singapore. And he did his studying in Nanyang Poly for industrial automation. Diploma, finished there. And then he became passionate with PLC already. At that time he was working in Wasport. We worked in a few companies and the last company he worked was in NSD. Last time was sharing from now changed to MSD. And then he became passionate with PLC. So the first PLC he touched was the Siemens S5, the older model of space. And after that he slowly moved to the rest of the brand. Then in 2010 he collaborated with his German partner in Germany, and they opened up AS Automation Services. We have another branch in Singapore, but they mainly focus on projects and services. So my boss, he opened up this company here. He wanted to focus more on training, but before that we kickstart to focus on services and project first. Then after that, in 2014 we registered ourselves as a training provider under HRDCorp Malaysia. And then since then until now we have trained more than 3,000 plus participants with a variety of PLCs. So yeah, I don't want to waste too much time on that. So and Tivian, he joined us in 2015 and his background is mechanical, and then he was completely trained by my boss. So I as a marketer, whatever project, services I bring in, I don't see that them. They gain that experience, we share it to the participant. That's how we conduct training. We touch a little bit of theory, the rest of it will be practical and so on. Okay? So, yeah. So this training will be Panasonic FP series, right? They call it that. FP series using the FPWin GR software. Okay, so this will be 3 days. 3 days training. Timing will be 95. Can be flexible, go on one tax. Okay, so at the end of the training, certificate will be provided. Prepare the certificate, and consultation is completely clear for all the participants who post our certificate. So I just need your IC, and then your email address. This one to prepare the attendance and the certificate. Because certificate I will provide with a hard copy on the third day of the training. I will give it to you. Digital copy I will give it to you.
Name, IC, email address.
That's all. Name, make sure it's full name according to IC. Okay. There's no another lucky or anything. According to IC. Okay. So I just pass it to him. Let him start training. Yeah.
The payment?
The payment, you want to settle now also can?
Yeah. But my boss requested to, usually after payment you will provide a receipt.
Official receipt we will provide, we will prepare and just email you or WhatsApp to you also can.
And then at the same time you can, after I have to make the payment, you just chop here and signature here.
Chop here and signature.
Like wait.
You want the round one or square one? I think round one should be okay. Okay.
So I do the bank transfer.
Bank transfer, okay? Give you at this process I can put a scale on.
Okay.
And yeah, Wi-Fi password, did you bring your card today? No.
I keep my bag.
Oh, right, okay. If you bring your card, you need to.
I think I just changed the transaction limit, so it's take a few minutes or 12 minutes.
Okay. Then later, you already saved already, right? I went there, just did it.
Okay. So you're using which software? FP GR7 or FPWin Pro? Because both can use. Check.
Then I
got the same model like you said. This is your model, right? Yeah. Just what I say. Because I am using different FP0. There's no R. But the same thing, same software. But this one more bigger. The arrows. So you know which software. Very good software. He said this is the main software lah. FPWin Pro. Means is like if you want to do bigger projects, can use this. The smaller one, then FPWin GR. Alright, so you are Mr. Ajay, right? Yeah, Ajay. So, what is your background?
My background is chemical engineering.
Chemical engineering. And then why you done PLC?
So this company I recently joined lah. So previously I did this project management, project engineer in Top Glove, Selangor.
Oh, Top Glove. So, which plant was this? How many plants?
Meru. Okay. So it's polymer manufacturing industry.
Okay.
So then I get a job offer in Singapore.
Okay.
They doing manufacturing gas detectors.
This company.
Yeah, this company.
They manufacture gas detectors. It means like CO2, all
And
that.
toxic gas like
Okay.
methane.
gas detector.
Yeah.
So they detect and convert the data into analog.
Yeah, they said now they manufacturing the instrument only.
Okay.
But they took me for another project lah. This
Okay.
one is about government project,
Okay.
PLC
Okay.
They do like they manufacturing one panel.
Okay.
They use their instrument to detect and then they analyze the data
Okay.
and then give lifetime results to the
The clients lah.
the clients.
Okay. So so in the in the control system you are using Panasonic.
Yeah. So for the panel they use Panasonic PLC to like from the process is like they take sample from the plant
Okay.
and then they got few pumps, few
Okay.
tanks to undergo lah, then
Okay.
go to the instrument.
Okay.
For that they use PLC
Okay.
to communicate with each instrument like sensors, float switch,
Okay. So
something
they're
like
using Panasonic.
that. Yeah.
This one.
Yeah.
Oh, okay.
I never seen this before because the panel is still in outside.
Okay.
So
But
my
the
manager just show
model-
me this
The
picture.
model lah.
Model.
Okay. Alright. Then so you need to do the programming part lah.
Now they already have programmed by the previous guy lah.
Okay.
So my boss want to learn something so I can edit if let's say they have process change.
Okay. So do some editing first. Okay. So have you done any PLC before?
Previously I worked in a plant also I just create the interlock in Excel, give my programmer to do the
Oh,
programming. So
okay.
I never experienced
In the
handling.
programming lah. Okay. Because Top Glove, they use so many models.
Top Glove use Siemens.
Siemens, yeah, Siemens. Because last time we come for training also. Yeah, Siemens, they have some plants, they have Mitsubishi also. Okay, so the HMI, what HMI they are using? Do you know what HMI they are using?
HMI, I'm not sure.
Okay, because HMI can use any model lah. So I will be using this WinTech. But this one we will touch on the next class lah. Next one is on the 15th, right? Yeah. So what you do, you create a folder in the desktop. Okay. And put your name. Okay. Then whatever project you do, you can save it here. So later on you can copy the files lah. Okay. Right. First you go to addressing Panasonic.
Panasonic.
So yes. Let's open the slide. Okay, so this training will be the Panasonic FP series. Okay, go to next. Okay, so what is PLC? So PLC is a controller. Okay, where we can program. Okay, it's a programmable controller for industrial to control industrial instruments. Actually, okay. So have you heard about Arduino? Arduino.
I got see university lah.
University normally using Siemens. Yeah, they do projects, right?
Yeah.
Okay, yes. So that one also is like a control. It's a microcontroller. Okay? That's why they call microcontroller because it's small version, right? Okay. And it's only normally they use for like university or college for the projects and everything. It's the same thing like a PLC also. Okay. But PLC are industrial standard. They use for industrial machine systems. Okay. Like microcontrollers, like they have Arduino, the Raspberry Pi, all that. They can control system. The same thing what the PLC can do, the microcontrollers also can do. Okay, we can program. They have their own software. Same like this Panasonic, right? Okay, but that is not industrial standard. Okay, because if you want to comply with industrial standard, you need to follow their IEC standard. IEC 611-113 or something. That is the for industrial standard. So this one all is Panasonic. Okay, all these PLC you can see. All these PLCs. Okay, these are Mitsubishi. These are Mitsubishi. This one all Mitsubishi. This one Panasonic also. This one is a FP0-H model. FP0-H. FP0R will be like this. This one, right? Okay. FP0H will be like this lah. Like this. This is only a few I/O lah. If bigger I/O will be like this, bigger one. Okay. Then we have Omron also. Omron models, and at the back that side you can see some Siemens. All these are Siemens. The green color are Siemens. Then this is GE Fanuc PLC. Then we have another as well. Okay. So actually all PLC are same. All PLC are same. They of course they use their own software like we're using like an iPhone right? You have Android and also the iOS, right? Two different OS, right? But the usage is the same thing, right? Same concept. Okay. If you learn one PLC, if you want to learn other PLC, it's easy to learn. But the first PLC you need to understand the concept. Don't try to like then when I teach, don't try to like something like memorize something. This is the way. No. Try to understand the concept. How the PLC works, everything. So it's easy to learn. Okay. Right. So let me show this is just an example lah. Assembly, oil and gas manufacturing. So any system you want to control, you can use PLC. I mean normally industrial standard lah. Okay. Even in the aircon you want to control also can. So normally aircon they have the PCB board, right? Okay. So what is the difference? Because the PCB board, of course, they have some IC to control the system. Right? Okay. There will be one IC where they load the program. Okay. Control the system. That is okay. You set the temperature. They will have a temperature sensor. Then once you reach the if the temperature is more than the set value, your compressor will on, right? Okay, compressor on, we take out all the hot air. Okay. So same thing, you can remove the PCB board, you can put a PLC there. So the advantage of using PLC is, let's say one compressor is not enough, you want to add another compressor, you can add another compressor. If one temperature sensor is not enough, you want to add another temperature sensor, you can add another temperature sensor. So that is the difference between a PCB board with the fixed programming and a PLC. Okay, PLC normally will be empty, so we only need to do the programming. Okay, So here we will learn how to do program, how to do download, upload, backup, everything, how to do program, and how to do troubleshoot also. Okay. Alright. So any question you just get. If not understand, just stop me and ask me. No problem. Okay. Only one extra. Okay. Next. Okay. So PLC at the same time sometimes they call CPU. Okay, PLC or sometimes they call CPU. But normally CPU means okay like this. This is a PLC, right? Okay, this is a like they call compact model lah. Means the input output together. Okay, it's also same. This one is like a modular type they say. So this is the power supply unit. This is the CPU. This is the input unit and the output unit. So sometimes they call CPU. So the PLC sometimes like this also they call Mitsubishi CPU. Okay, because it's like industrial computer, right? So they call CPU. Okay. So if I have an input module, CPU output module is like a complete PLC lah. Okay, if only CPU only, then you cannot control anything. Alright, okay. Then inputs we have a digital input and also analog inputs. Okay. So digital inputs like example like sensor, limit switch, the push button, the proximity sensors, the flow, like you said, the float switch, everything, right? Okay. So very simple. Any signal that is on off is a digital. Okay. So any signal that gives will go to the PLC as just on or off is a digital signal. Okay. Analog input means they have a value, they have a range. So like you said, they want to measure the toxic gas, right? The methane, everything. So of course, so they need a range, right? So normally you will, if your methane means you will calculate in ppm, right? So parts per million, right? So parts per million. So of course, the instrument can detect the methane, right? Parts per million, but then this what instrument need to send a signal to the PLC, right? So they can be like two types of signal. One is the communication. Okay, means have you heard about RS.5 Modbus? Okay, Modbus. Have you heard about Modbus? Okay, so it's a communication, right? So means your PLC send and receive data using the Modbus protocol to your instrument. Okay, so you can get the value left, right? Or they can use analog signal. So analog signal means like they will measure. So let's say this can measure this one 0 to 100 lah, example lah, 0 to 100 ppm. Then it will convert the value into voltage or milliamps. Then you connect to a PLC. Then in the PLC you will get some value. So it's not like 1 or 0. So it is a range. So very simple. Digital means 1 or 0. Analog means range value. Then later on we can do some calculation to do the convert back to ppm. Okay. So once you connect the inputs, okay, I program the PLC. Then the PLC will control your output according to your program. Very simple. Okay. So the output will be on and off according to how we do the program. So the output can be same, digital output and also analog outputs. Okay, digital outputs, example lamp, contactor, motors, relay, valve, right? Okay. What else? So many things. But like a pneumatic systems, right? Pneumatic valve. Okay. Then like a lead. What else? Because normally go to the relay. From the relay only they go to the devices. Okay. So contactor, of course, they control motors, right? So relays, they can control valve, normally solenoids lah, right? Okay, solenoids. Then same thing. Is that digital output means 1 or 0. So because lamp, you just give them like this lamp, right? Just give them the positive, negative, right? So negative already from the power supply. Maybe the positive you give, then the lamp will on. So means just one on, right? Then your contactor also same. Okay, you give them the negative signal, I mean the voltage, then you give the from the PLC you send positive, you can on. Or other way, from the power supply you give positive, then negative from the PLC also. Okay. So analog means same thing, value. So normally analog control what? Like a motor speed, pump, and valve. Because some valve is just open, close. Some valve you can open like percentage, 10%, 20%. So how much gas you want to release, everything, right? So if you have a value, then it's an analog output. Okay, good. Then of course, all these modules need a power supply. Okay, to power up the PLC and also the input output need to give the signal. Then only I can get the output or the input can activate everything. So later we do some wiring. Okay, for this. But one annoying part is that this one is not like normal screw type, like a connector. Okay. Then whatever PLC use, most important is what is the software and the cable. These two is very important. Okay. So because if you have a PLC already have, so because I assume your current what you want to do after this is you learn the PLC, so the program is already done. So you want to do a small changes, right? Small changes, then you want to add something, right? Okay. So for that, the most important is the cable and the software. Okay. So do you have the project file?
Yeah.
Okay. Good. So later we can see the file, so I can know. So which one to teach you, so we see. Okay. All right. Any question here? Yeah. Okay, go to next. Okay, computer numbering. Okay, so computer numbering. Actually, we learned before all this. Okay, decimal, hexadecimal, binary lah. Octal, I don't think so. We learned before. Octal very rare. They teach in our University of College now, right? Okay. But hexadecimal binary, sure lah. But chemical, I'm not sure. Teach this one? No, right? Because I also can. But my background also not electrical. My background also mechanical. I come here with the this. But the thing is, to learn PLC, the main important thing is you know how to use computer first. That is the most important one. Because this involves software, right? Okay. Then first computer, then second thing is try to understand the concept. So when you understand the concept, then slowly you can learn. Because of course these 3 days is actually not enough. Okay, because these 3 days is I can teach you how to use the software, the main thing, right? How to do a small programming, then how to debug the program. Okay, then I teach you if you see something new, okay, how to understand the functions. Okay, PLC inside the program they have functions. Normally they will have, like you say, interlocks, right? Okay, some interlocks, some outputs, then some functions. The function is the one controlling the system. Okay. Next. So later on you can copy this slide also, huh? Okay. First decimal. Okay, decimal is the number we use every day. Okay, so 0 to 9 and so on. So can consider 0 to infinity, right? Okay, but they call it's using base 10. That means the normal number 0 to 9. Okay, all the numbers. So this is common. So this is the number mostly used in programming in the HMI. Okay. Then we have hexadecimal. Okay, hexadecimal mostly used in PLCs, computers, and some digital devices lah. Okay, hexa means 16 digits there. So it means they start with 0 until 9, then continue with A to F. Total will be 16. So after F, then they have 10 to 19, 1A to 1F. Okay, 1A to 1F. So let's say decimal. Okay, 0 to 9, right? Then continue lah. Okay, so hexadecimal 0 to 9 is exactly same like decimal. Then start from A to F. Okay, so if I convert hexadecimal A in decimal is 10, normal number lah, continue, right? Okay, then if I just continue, F means is a 15, then continue lah. Okay, until example 19. Okay, so now here start the second batch. So 10 to 19, 1A to 1F. Then continue. So 20 to 29, 2A to 2F, 30 to 39, 3A to 3F. Okay. So why they use these numbers actually? Because actually hexadecimal all is like the older formats lah. Okay. Actually, why computers they using these numbers? Okay. Because if you see later on life, when the number go bigger, okay, this hexadecimal use less digits compared to normal decimal number. Okay, so later in the in the calculator we can see. So they use less digits. Okay, so for example, you can escape this. You go to calculator. Okay, so normally our computer calculator is actually come with a programmer. So you click here. So normally will be standard. So all the computers we have. So no need to download it's not a special calculator. Okay, so if you click programmer, then you will have all this. So let's say in decimal, right? You put 20,000, for example. So can you see 20,000 in decimal, in hexadecimal is a 4E20, right? Okay, so you see here got 5 digits, right? Here only 4 digits. So previously what they do, they use mostly in computers in hexa format because less digits. So for them to easy to calculate, easy to store the values and everything. So that is the reason they come out with this hexadecimal flag. Okay? Alright. Can we minimize this? Okay, continue. Okay, next. Okay, next is binary. Okay. Binary, okay, we know 0 or 1. Right? Okay, very simple. Okay. So it means okay. So binary is 0 means 0 lah, right? Okay. 0, but normally they will have come with like how many bit we call bits lah. Okay. Then if F, it means you can get 1, 1, 1, 1. Okay. Okay.
how this one you can get can use the calculator to get the value lah. But how we get this one? Very simple. Okay. So binary means what? Base 2, right? Okay. This one, of course, you can use the calculator. I just give you the concept how it works, so it is easy to remember. Okay. So base 2 means, okay, so it is so base 2, so 2 to power of 0. I mean the first, always they call bit lah. The first one 0, then 1, 2, 3 lah. So bit 0, bit 1, bit 0. Supposed to be start from the 0 lah. Okay. Like input lah, the first input, second input, right? So always PLC start with 0. Okay. So 0, 1, 2, 3. So if I put a 2 to power of on this, okay, I can convert to, so 2 to power 0, 1, right? This one is 2, this one is 4, this one is 8. Okay. So these numbers they call is a BCD numbers, binary coded decimal. Okay. Then in decimal, very simple. Let's say I want 10, means 8 and 2, right? So means this bit, the first bit is not on, so it's 0. Okay. Second bit 2, right? So means it's on, it's 1. This bit I don't need 0. This bit I need 1. So the first bit is 0, second bit is 1, third bit is 0, fourth bit is 1. So if you see second bit and the third bit, second bit and the fourth bit, right? If you convert into BCD, it's 8 and 2. If you plus this one, you can get it. So that's how it works. So for example, if 15 means all must be on. So 1, 1, 1, 1. That's how you can get these values in binary. Okay. This is just to understand that. But normally, if you want to convert, just can use the calculator to convert the values. Okay. So last time, in our school time, we learned how to use calculation to convert these values, right? Actually, okay. Then octal. Okay. Octal is using 8 numbers only. Okay. Mostly used in PLC. Octal. Okay. That's why if you see we don't learn octal. I can't remember also in school time we learn octal also. Because of course I remember we learn decimal, hexadecimal, binary. Octal I can't remember we learn because it's normally not used in computers, it's used in PLCs. Okay. So they have 8 numbers. It means 0 to 7. Then there's no number 8 and number 9. Okay. So they continue with 10 to 17. So it means 0 to 7. There's no number 8 and number 9. Then 10 to 7. So in decimal 15, in hexadecimal is F, in octal is 17, in binary is this number. Okay. Now, so they have 4 types of numbering. Okay, this one is a very basic one lah. Okay. Okay. Now, you see, this decimal, hexadecimal, and binary we use as a value in the program. So sometimes you see in the screen or something some values, right? Most of the time is decimal. Okay. When we use hexadecimal normally when we do advanced programming. Advanced programming is what? Example, the PLC want to control a motor, the motor speed using communications, not like hard wiring, using communications. So when of course if you want to, even the same thing like I said, your instrument, right? Gas detector instrument. Okay. So let's say if I'm using the analog, means just like 2 wire. So 2 wire connect to PLC, you can get the values. Okay. But let's say if you are using Modbus, communication to get the data.
Okay.
So of course your instrument has the data sheet, right? So in the data sheet, okay, they will say, okay, if 0 to 100 ppm means in the PLC, okay, they will give some value. Sometimes they use hexadecimal in the manuals because it's just using 4 digits, okay. And why they use hexadecimal? Now the main difference lah, hexadecimal only have positive values. Normally, okay, it's just a positive value. Decimal normally can have a negative positive values. So that is the difference. Okay. Then of course binary they use. Octal normally they use for addressing, like an input output. So you see that PLC there. Can you see the address there? They write down very small there. X. Yeah. Right. Okay. So you can see here. You can see X0 to X7, right? Then continue with X8 to F. So it means they use what? X. Yes. They use the hexa method. They use the hexadecimal. Okay. So some PLC using octal. Like if you see the Mitsubishi, it start from 0 to 7, then 10 to 7. They don't have others. So actually Mitsubishi got both. If you see this one, the white color, right? All the white color they using octal method. So 0 to 7, 10 to 17, 20 to 27. If you see the red color, the big one, this one is using the hexadecimal format for their addressing. Like Siemens, they using octal. Okay. Omron, they use a decimal method, normal number lah. So no need to confuse all these numbers. Okay, like elementary they use this number, but nowadays most of the PLC they start to use this number, decimal. Actually nowadays most of the PLC start using tag based programming. Tag based means no address, like this one address, right? X0 input, right? So nowadays a new generation of PLC no like address. They just using tag name. So okay, start, stop, so no addressing formats. Okay, nowadays because Siemens, yeah, the new one Siemens they have both address and also name. Like see, elaborately they just using the name only, no address already. Omron, the old one got address. The new model, no. The new model using the name. So because nowadays all the PLC now want to connect to the cloud system or there, right? So when they're using this like a name, they can export this tagging, export to Excel sheet. Then in the cloud you can use import and use. Okay, good.
set of number? Or?
No. We go bigger. You go to calculator. So it's based on the number. If the number go bigger, then the number here also go bigger. So later inside also some details about this line. So they call actually binary they call bits. How many bits? So like 4 bits means maximum can go 15. The value, because if all the 4 bits on 111 you get 15. So if you go more than that, so it means the bit is bit 0, 1, 2, 3, then bit 4, 5, 6, 7, right? Then if everything you do this, then it becomes 16, 32, 64, 1, 2, 8. Then the number can get it bigger.
Again, PLC can accept 8 bit and 8 digits.
No, 8 bits. No, not PLC accept. PLC can accept up to 32 bits.
32 bits.
Yes. So means because they have a 16 bit and 32 bit normally lah. Okay. 8 bit very rare because 8 bit and 4 bit of course I don't have. Okay. 8 bit also some PLC only they start their addressing with 8 bit, then the 16, 32. Some PLCs straight away 16 and 32. These two. And Siemens they have 8, 16, 32. Like Panasonic all is 16, 32. Like most of the PLCs 16, 32. Because they want to store value. So like you see, 16 bit you can see can store 20,000. So of course if all on whatever.
20,000.
No, if all the binary at 11111, then the value more bigger.
Just double check.
Okay, can we minimize this? Next. So this example lah. Okay, next. Okay, this one how to use the calculator. Okay, next. Because sometimes some they don't aware of this. Okay, alright. Now, so this is the I/O allocation for your PLC. Okay, so the FP0-R PLC. Then they can add I/O expansion, 3 I/O expansions. Okay, 3 I/O expansions. Okay. So you can see here, like they have a model called C10, C14, C16, and C32. And this T32, F32, they have a meaning lah. Later I will tell you what is that. Okay. Then so 32, that's why they have a 16 input, 16 output. 16 right? So 16, so they use X0 until XF. So output they use Y. So input they use X, output they use Y. Okay. So if let's say I add another like expansion, because that one can use the expansion. If you see there's a small sticker there. Expansion connector. If you remove the sticker, there will be some pins to connect the what can connect the module here at the side. Okay. So it's not a CPU. So this is CPU. This is the PLC, right? Same thing. CPU. Then later on we can add more. That is called expansion modules. So if you add expansion modules, okay. So the first unit can go to X20 to X30, so another 16. So then second unit another 16 input, 16 output. then 16 input, 16 output, 16 input, 16 output. So total 416, so 64 input. Right. So 64 input, 64 output total for this model. Okay, FP0-R. Total lah if you add 3 expansion modules. Okay. Go to next. Okay. This is their addressing format. Okay. So this is for FP series. Okay, not for FP0-R, FP series. Okay. So you see the input can go up to 1760 inputs. Means can go up to 1760 inputs. Okay, but not for this model lah. FP means all the other models also. Okay. So this is here their addressing. Okay, X0 until X109 F lah, because it is using hexadecimal. Yes. Okay. Then this is the IEC format. So this one we don't need to care lah. Okay. In IEC format, because in IEC format they don't use hexa. They use a decimal method. So 0 to 15. Okay. So what they do, for example, so in Panasonic PLC they get X0 to then X9, right? Then XA until XF, right? 16, right? So if it is in IEC standard, of course they will have this format. Okay. Then I means is the input lah, right? Input X 0.0 until of course X 0.9. Then they don't start with A, no. They will start with 10 until X 0.15. So they use, this is the first batch lah, X0. Then come with the X1. That's why you see here it go up to 109 F means is a 4 digits, right? But here only can you see until 109 only. So means they're using the 16-bit method. So 110 here they have a 16-bit. Then they go to X1 at 1.0 and until 1.15, something like that. Okay, but this one you don't need to care because this one will be later on automatic. We just put it here because we will be using this one. This one will be our IEC format. Okay. Then so this one is the input and output, right? Okay, so they have a function here also. Okay.
Meaning we can put 1760 input.
Yes. You can accept 1760 inputs. Okay. But of course we don't use that much of inputs. Okay. Then they have a internal flag. Okay. So internal flag means is used internally by the PLC program to store bit information. It means this is like a do you know relay? Relay, right? Like an internal relay. So means it's like this memory, this address R is only can be used inside the PLC. Okay. So there's no wiring like the input or output. So it's just like inside the PLC. Okay. Then we have a link. Yeah, this is called like a link relay. So link relay. Link relay means is a shared by multiple PLC. Connectivity means like this PLC Panasonic and like connect with another Panasonic. So if like say these two Panasonic PLC want to share data, we use these addresses. Okay, but very rare. Normally we use this. Of course timer, right? Of course we need to have a timer. Then counter, they use C. Okay. Or the thing is they using the same number. Timer and counter, they using the same numbers. Okay. So it means you want to use counter starting from you can use this number also, okay, this number also, okay. But you cannot mix. Later we see that. Later we see this one. Okay. Then this is a special internal flex. Means it's like a special internal relay, special memory lah. Okay. This is also called memory. This is also called memory lah. But this memory is user defined. You define. Okay, R0 is what? Okay, let's say when I press start, I want to use the R0 as my like condition, like all on condition, something like that. R0. Then when the temperature is, let's say like the pressure, I mean the gas detect is over my set point. Okay, then I on a memory. That is the, let's say R1. So R1 means it's a the methane gas is more than 50. Example lah. Okay. Then this condition later I can use as the interlocks for my programming. Okay. Means this one is you define, user define. This one is they already defined for you. Omron, the Panasonic already defined for you. Okay. This is the PLC. R9000 means this one. R9001 means this is the meaning, something. So later in the manuals you can see that. Okay. Then in the program also, your program also they should use this. Some lah, not all. Because normally from here I will get data like always on. Means the particular memory is always on only. When the moment your PLC go to run, the particular memory always on. So later we use that. Okay. Go next. Then we have this is for analog inputs. Can you see? Code for specify 16 input as one row. It means because like I said, digital input is this on or off, right? So analog input means you must have a value, correct? So if I need a value, so I need a bit to store the data. Maybe 4 bit, of course cannot lah, 4 bit very simple. So maybe 8 bit or 16 bit. Because if you see 8 bit and 16 bit, 8 bit is until 255 only. Maximum. Because if you add all these, you will get 255, which is considered small. So that's why they use 16 bits. 16 bits can go up to 65,000. But depend on the PLC lah. They want to use. Normally they don't use up to 65,000. They use maximum like 30,000, 25,000, sometimes 5,000, 10,000. It depends on the different PLC. Okay. So means the value of your analog device, let's say the temperature, for example, if you go to, we use WX. WX0. So it means WX0 means is a 16, means inside that there's a 16 bits, but we won't be using the 16 bits. So means it's already at 16 bits. So the temperature value can store here. Okay. So later on we can see all this. Okay. Then what else? Then the output. Okay. Then the internal flex. Same thing. Okay. Same like just now. The one what they call. Just now I have another R, right? The R9000 above is internal, right? that is the internal bits. Okay, means if always on signal, always off signal, okay, like you need a pulse, then you can use that.
So say for example, for the temperature sensor,
Mm.
I name it at WXO.
Yes,
It can store until 16 bits of value.
yes. Because why? Because analog, you need 16 bit of data to keep this, to store the value. Because if you ask me, the lowest number analog value is 4000. The lowest. So of course, 8 bit cannot store because 8 bit until 255 only. So more than 255, of course, I need 16 bits because there's no such thing like 12 bits. So for 8, 16 bits. So that's why I need 16 bit of data. Okay. So for example, okay, how it works is, okay, let's say the temperature is 100 degree. So it will convert into analog data. So analog data means it's like a voltage or milliamp. Okay. So let's say it is 20 milliamp. Then 20 milliamp I connect to my analog input. Then inside the PLC, it won't show 20, it won't show 100. Because 100 is in Celsius.
Yeah.
Right? 100 is in Celsius. PLC cannot store units like Celsius, pressure, all that. So it cannot store units. Okay. Now, what happened in the PLC? So it will store like a value. So one range. So Panasonic later in the manual will see. Okay? Because I don't have the analog also. But I can show you like, because these 3 days training we don't learn analog also. But I can show you on the last day, I can show you like what is the value we are using. So for example, in the PLC, let's say it shows 4000. So means actual temperature is 100, but in the PLC it will show 4000. So the 4000, to store the number 4000, I need 16 bit. So this is where it will store the number. Okay? Alright. Next. Okay, so it's also same the link. Okay, so not very rare we use the link or set value, set value. So just now you see the input is the X, output is the Y, then R is the we call it internal relay line, right? Okay, these 3 we use. Okay, the link relay of course we won't use because we are not connecting PLC to PLC. Okay, then of course we are using the timer, counter. Then other than this, we will be using this data register. Yes, data register means the same thing. Need to store 16 bit of value. Okay, because like just now for analog input, right? Okay, the WX0 analog. After I take the analog input, like I said, temperature is 100. In the PLC is 4000 for example. Now as a programmer, I need to convert that 4000 into 100. I need to do calculation. I need to show in the HMI one. Okay? Because I cannot straight away show the 4000. Nobody will understand. So I need to convert the 4000 into 100. So I need to do some calculation. So when I do calculation, I need to this one. When I do the calculation, I need to, after I do that, I need to store the temperature value into some place, right? Of course, I can use analog. Analog means it's from the output. From the field. So I need to store here in the data register. Okay. So data register is like a internal memory which is 16. Similar like the R. R is internal memory which is 1 bit only. So it can store only on or off. Data register means is an internal memory which is 16 bit of data. So means it can save like values. Yes. Okay. So for these models, I have only this much. If a 32 IO1, I have until 32,767. Okay, good. Okay, then we have a timer value and counter value lah. Okay, it's all later we see. Okay, then Same thing like this, same thing like just now, special R, right? Same thing here. But the special R only can store like a signal of 1 or 0. Okay? Means if let's say the PLC error, so one of the R will be like on. So you can use that for programming. Alright. Okay? But here if you store like a value, later we see all this. Okay? Because I need to see your program, how they use their program, so I can get an idea which one they use and everything. Okay? Next. Okay. Until the addressing. Any question? Maybe I think use in the programming, then you can understand better, right? Okay? Alright. So yes. This is the what the byte and word. 16 bit, okay, 8 bit they call byte. So you see, if all the 0 to 7 are 1 1 1 1 1 1, I get 255. So if 16 bits, right? If all 1 1 1 1 1, I get 65535. So that's why they use the 16 bit data to keep the value. Okay, good. Go to next. This one maybe later. Later we see. That's all. Okay. We escape. Okay. We can minimize this. Okay. So the first thing now, what we want to do is we want to do a backup. Okay, the backup. Okay. So first thing, you connect the USB cable. Yeah. You can take out like this. According to the PLC. Yes. Excellent. Okay. So you can use this other port also, right? You can use the other ports also. That is this cable. Yes. Okay. So when you connect the port, you go to here, device manager. Go to ports. Yeah, you open. Okay. So it's a COM4. Okay. So whenever you install the software, this driver also automatically will be installed. When you install the FPWin software, this driver automatically will be installed. Okay. So it's just a normal cable. It's not like a special cable. A normal USB, USB A to USB mini. Okay. Normal. Okay, if you don't have like this, sometimes what happen, if you go into others, now don't have others, right? Okay, sometimes if you go into others, then it asks you to update the driver. So you need to update the driver. So how to update? So you need to get this name. This name from the manual you can get, the hardware manual. Okay, you can get that. You can get this name, then you can go to Google, you can download this. Okay, right. Now COM4. Can you close this? Okay, this is the software. Open. Okay, load a project from the PLC. Okay, go to communication setting. COM4, right? Okay, this one by default lah. Okay, click OK. Yes. Okay. just this one testing program. Okay, so that is how we upload. Very straightforward. Okay, then we can go to project, save as, go to desktop in your folder. Just upload day one. Okay. Alright. Can close this one. Okay. That is how you upload a file. Very straightforward. Okay. You can use this one also. Okay. This one is like a more advanced version. That's all. This both are same thing. Okay. This is the more advanced version, more professional. They call professional. Okay. And got so many models you can program here compared to here. Just only some models. Okay. Okay, you open this. Okay. Okay. Create new project. Is only this type of model. So FP7, these models, then FPX. Yeah. So FPX will be something in this one. Like this model, okay, FPX, FPXH, X0, all same, like that model, okay. FP sigma, no, I haven't seen before. Okay, then the 0H, FP0H also same like that, but bigger model, okay. Then FPOR is this model, yours is a C32, yes, okay. Then we have a C16 on that. Okay. If you want to program this one is the FPO only, not FPOR. Okay. This one you cannot program here because they don't have. Right. So you must use the FPWin Pro. Okay. That's why because you said you wanted to learn this, right? This software, right? That's why I buy that. Okay, because this one can use no problem, but you only can use the FPWin Pro. So it's totally two different softwares, almost similar, but I mean the layout wise is always so much difference. So I buy it. Okay, you can buy one like this. I mean you ask your company to buy one like this. Set up like a training kit. Okay, not very expensive. So I buy very cheap. I mean second. Around 600 rupees. Yes, PLC and also the connector as well. But this one must have a ribbon connector, right?
The connected, this one.
No, the ribbon connector as well. Connect it.
Because you must use this type of connectors. Then later when we do wiring also we need to follow this. So we take this two.
Then of course this one you need to take out and need to later I will bring one wrong one. So then we can just connect to like groups. Then later we do somewhere. So because this one got how many? 10 connectors, but you see only using 8 only. So it means all the time not using, only using 8. So in the manual later we see in which pin using which number. Then only we can do the wiring. Then we can do the again. Okay, then you can connect, do like this lah. Later we connect to here.
Okay. Either that maybe the PLC we put it here.
Then we can use the push button inside. So then you can create one simple kit for you. Then you can practice. Because you know why sometimes without the hardware you can practice also. Because this one got simulation. Only the hardware. But some system you need to use the hardware to practice. Then only can easy to understand. Because the hardware is very important. You know why? Because sometimes when you download, suddenly the hardware give you problems. So you can learn something. So you know, okay, if I do this type of program, my hardware can support. Whereas in the simulation it cannot show you. Okay. Okay, choose the FP0-S. Okay. Close this. No, not that one. Go to FP0-7. This one nice. Don't like this one. The FPWin. You close this. Later we can add the input field bar close. All like that side. Yes. The one last one also close. Yes. This one, yeah, I'm leaving here. Okay, go to view. Project window. Okay, you click here, drag. Bring the mouse to here. Yes. Okay. So it must be attached like this one. Okay. Okay. So this is where we do the programming and everything. Then here we do the I/O comments. Okay, you click here, double click. Okay. So we can give the I/O comments. So this is the X. Click here. See, X, Y, input, output, internal. Okay, like I said, right? R is the internal relay, correct? Special R is a special relay internal. Special R, timer, counter, link relay, then external input word, external output word, then data register, special data register, all this. Okay. And this one all is the instructions, like the functions lah. Okay. So we choose X, yeah. X0 is X0 is what? Let's say you put start. Okay. The next one, put a stop. Okay. Then you choose Y. So one output, let's say motor. You choose Y, then you double click here, please. Okay, click here. Now the function bar is here. And normally open, normally close, everything is here. Okay. Take a normally open. Here. Then no need to click. Just key X0. Can key it? Yeah. X. Yes. Okay, right? Okay. Then the output. Output is this one.
Y0. Then I choose this one, the branch. Yes. Y0. Yeah. Then click here. Okay. You use not. No, not this one. Escape. Okay. You put the normally open. X1. And then you right click this. Right click here. No, choose right click. Okay. Then you put a not. Yes. Yeah. Okay. X1 enter. So from open. So when I on this one, the motor will be on. Okay. Later when you do wiring, you can easily understand. So means this is the input, right? Okay. So when I press start, the motor can be on. Then I can use the motor to hold. Okay, why? Because this one we call normally open. Okay, this one we call normally closed. This one we call coil, like output light, right? Okay. So the coil is depend on the line. If the line is on, the coil will be on. If the line is off, the coil will be off. Okay. So what happens is so this is a push button, right? When I press, so it's a normally open, right? So when I press, it becomes close. So you can give the signal. So when I press, I on, okay, I give the signal. When I release, I will I cut off the signal, right? So if I use the coil only, it cannot keep the value. So that's why I use the same address as a normally open. So how it works is, can I erase this?
Okay.
So X0, Y0. So it means, so how it works actually, this one is like a wiring diagram, you know. So here is the input, so here is like a 24 volt, here is the 0 volt, like a single line diagram. So means 24 is right here, okay, then 0 is right here. So switch, so normally open means it's like a switch. Switch, what is the function of the switch? Switch pass the signal. So when I press on, so it gives the signal, so on. Right. If I release, then it's off. Right. So then my output also will off. Now so if I use the same address here, so when I'm on this, okay, give the signal to here, then wherever I use the Y0 any place, every place also on, right, become 1. Okay, so here become okay, on, it will be latching this. So the moment I take out my hand from the start button, so it will off until here. So my output will be still on using this signal. Okay, so that's how it works. Okay, now if I want to off this signal, of course I need to cut off this latching. This one we call latching, okay. Latching or holding. Okay, latching or holding. Okay. So I use a normally close X1. So it is a normally close. So when the input is on, energized, so it will open.
open, so it will cut off here. So when I cut off Y0, if this one off, here also off. Then entire everything off. Then when I release, then it become normally closed. So that is the function. Okay, you got it? Okay. So now what we done? So once we done the programming, so that's very simple. Create new project, then choose the PLC model. Once you choose the PLC model, you go to IO comment. You can put all the comment if you need it. If you didn't put the comment, also still can. Okay. Then you write the program. So choosing this one. This one is the annoying thing here. This is because you can use the shortcut. So 1, 2, 3, 4, 5. So can function. This one is the function 1, 2, 3. The FN. Then shift 1 is this one. Control 1 is this one. Okay. Now, once done this one, you go to convert PB. Yes. No error. Close. What is PB actually? Your program block. So this one is a PB1, right? Program block 1. Okay. Now, no error. Okay. Go to online. Go to communication setting first. Okay. COM4, right? Okay. Then go to online again. Switch to online mode. Yes. Sorry. Close. Go to online. Actually, it's already online already. Actually, you need to download first. Yes, download to PLC. Yes. Okay, it's wait. Cannot execute because cannot execute because the PLC is in run mode. So you can see the run LED on the PLC. Yes. Okay. So switch the PLC from run to program mode. Okay. So there's a small switch here to on and off, right? Okay, you can use that also can, or if you click yes, the software itself change to program. Okay, yes. Now you see, is it in run mode or program? Program. Okay. So the download to PLC was complete. The PLC will be switched from program to run. Yes. Okay. So can you see, of course, you cannot see the line is on, right? Only can see this particular icon only. Okay. So now you are, can you see, now you are online. Online and PLC in run. So what error means, it will show red color error. Okay. Now you double click here on. Okay. Cannot because we need to use push buttons. Because why? Because X0, because some PLC can on, but it cannot be like always on like the one pulse on it, like a big can on, like Mitsubishi all can on. But that's only this model can. FP0H can. FP this one cannot. Okay, because this is a physical input. X0, X1 is the physical input, so you need to do wiring. Then only can. Okay. Never mind. Later we do wiring. So any question until here? What? Okay. Alright. So go to online here. Switch to offline. So if you want to edit something, must be in offline. Yes. Okay. You can see here or see here also. Sometimes it shows monitoring. Okay. Save first. No, the day one lesson 1. Okay, any question here? Huh? So take a break, then after the break we continue. Okay.
So you want a coffee or tea? You can pick up. R, right? So this is all X, 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 X. It's a regular principle. R is the, the internal relay. Similar like a push button, but on inside. Relay. Then we use a timer, let me see. Set. So now relay.
Set is the internet relay.
No, set is like the numbers is the relays. This one is we call instruction. Like normally open, normally close. The output we call instructions. Okay. Then this one all the timer, right? It's a timer. This is a set instruction. Set reset. Okay, all timer. So we don't set reset. Then keep all X relay. So many things. It's not about HMI, is it? For HMI also. Okay. For HMI also they use relay. The HMI buttons, right? They use relay. Can you see? R901C is a 1 clock pulse. It means the R9 normal R0 until some range, right? Okay, it's a user defined. You define. Okay, this R is for what? Okay, like this. They say R41, right? So they put 20% level R or something. So they define. Okay, R41 is 20% level R. And later on they do some programming lah. But this one is a Panasonic fixed this number. So means R901C is a 1 second clock pulse by default. So this is a default relay. So if anywhere you want to use a pulse, you can use this. You don't need to create your actually it's a 1 second pulse, right? You can create your own pulse also using timer. But they have already given you the relay. This one we call system relay. One is a internal relay for user. One is for system relay. System internal relay or something like that.
Instead of you creating one line for the timer, you just
Use
give the default one.
Yes.
As a input.
Yes. If no, I need to create my own 1 second pulse. Something like that. So here's the output. So can you see how they do your program, right? Okay. They use the X. Then when the X is on, okay, they create the that. Then if you on a relay, I mean the R, internal memory. So then they do the few things. Then finally they put it here. So actually, what they do Y0, right? They link to R60. So in the program, wherever you want to on a Y0, let's say Y0, I don't know what output is that. Let's say one output transfer. Valve, okay, valve, okay. Let's say I want to on a valve. In the program above here, they use R60 as a valve for the representative for the valve. R60. They do everything. Finally, they put it here. So if the relay is on, if R60 is on the valve, but they put some interlocks. These are all interlocks.
Last time I go through with this one. What I understand is the R60 they do for one process. Like this one R60 is a rinsing process.
Okay.
So rinsing is they just suck the water from the pump, raise the tank, and then go up. For that they need to open this valve. So
Yeah, that's the thing. But how they do here is, okay, normal, like this, right? Like I put in the X0, then output Y0, right? What they do, instead of using output straight away Y0, they put an R. Okay, like temporary, use R, okay. Then, anyone want to on the valve, use the same R. So let's say I press start, okay, I need to on the R60 for example. Then if I press stop, okay, I want to off the R60. Then later on, they do this one we call IO mapping. Later they link this because instead of using this R60, right, wherever I use the R60, I can straight away use the Y0 also can.
Oh, straight away.
Direct like this also can. Okay, actually what they do, like I show you here. Because it's not common, many programming has seen before this. Okay. So I do a few that you do understand. So they put R10. Okay. So this is the start, this is the stop, then this is the, let's say, valve. Okay. Then if let's say timer done, okay, need to on back the valve, okay. If X3 on, if something like this, right, X, so many condition for the valve. Then later on, what they do, they use R10 on the Y0, so make it simple. So they do mapping here. So now here I put the most important interlocks, I put it here. So okay, this one, if alarm is on, if there's an error, I cut off this or something like that. So actually what they can do, they take these two, right? They can put it here also. They can put like this. Instead of using like this, I don't need to use the R10. I can straight away use the Y0. Okay. Then this is the two condition, right? Additional condition. Okay. I can put it here also. Then Y0. It's the same thing, right? But will be more complicated. Because these two is like important for all the outputs. So they do like this. That's why. So instead of using this, they don't want to do like this. So they just make it simple. So for them also easier. So R10, later on I put it like this. Something like this lah.
So maybe they think for the process flow first.
Yes,
They
yes.
then consider the alarm. Then they combine the everything in.
Yes. So in here just the process flow only. Then later on, okay, according to this process, this memory need to on. This memory actually replacement of your valve. So later, when the valve on, actual output on. But I have some conditions here. If not everything I can put in one line, so it will be like so big. Because I say your program is very straightforward, not so complicated. Because I have seen sometime like this, but normally what I do, some programmer, how they do, not only Panasonic lah, I'm talking about all the models lah. So sometimes what they do, even X also what they don't use. What I do, they will do like this again. They use R0, like start, let's say R10, and latch, R10, R1, something like this. So they use internal memory to do the programming. Later on, they do the mapping. Means, okay, if X0 is on, okay, R0. If X1 is on, R1. If R10 is on, Y0. Something like this. So instead of using the X straight away, they use this one. Later on, they do mapping. You know why do this? Okay, sometimes some programmers, okay. You know why? Because sometimes, let's say I'm a programmer, okay. So I'm doing a project of course like for big projects. Here means I will do the wiring. I'm the one doing the programming and everything. Like that's why normally I don't take big projects. I only take small projects. Okay. Like if you have big projects, one group they do wiring, one group they design the wiring like that. Then maybe one group do the PLC program. Okay. So for the PLC program, the most important thing is the flowchart and the I/O list. Okay. Flowchart is your process flow lah, because you are familiar with the process flow, right? Okay. Process flow and the I/O list means the input output list. Okay. So sometimes, they give you the input example Y0 as a valve 1, but later on after they do wiring, they change maybe Y1 as a valve 1, Y0 they use for something. Because it's one very common happen because when they design a panel, because who designed the panel is the guy who designed the drawing. He going to design the panel. So when they do the wiring, sometimes they find okay, this one cannot because this one need to use additional input, additional. So they do at the side, they do some modifications. Then later on they will update the wiring diagram as well. So when they change that, my program also need to change. So what if the program was they will do in memory. Of course they will assign first for their own this one. They will assign okay, R0 is the start button, R1 is the stop button. So later, once you finish, once you finalize your wiring, you give me the I/O list, the new I/O list. Then I do this. Let's say initially they say X0 is the start, X1 is. Let's say they already changed. X1 is the start, X0 is the stop. What do I do? So I need to go and change the program. So if I do it like this, so I just change this again. So X0 this is stop, okay. R1. X1 is the start. This one they call I/O mapping.
So the X and Y is the original input and output.
Yes, correct. X is the input, R is the output. So
And
X is the input, Y is the output. R is the internal memory. Actually, they call it internal memory lah. So many things, internal memory, internal relay. They call some like Mitsubishi. They call auxiliary relay. All of them. Okay. Alright. So that's what they do in your program. Okay. Now what we do before we proceed, I think we need to do wiring first. Okay. Are you familiar with wirings?
Wiring, no.
Not familiar. First thing is it the Wi-Fi is connected in your lab in this lab? No. Okay, find the Wi-Fi. Show you. Okay. Actually, regarding PLC, there's a manual there also, right? The manual later you give here is the very basic one. Okay, you can see what is the PLC, the complete number system you see, right? PLC data type, I/O allocation just now you see, right? How to start up this one, create new project, upload, how to upload, then what is the menu screen, everything, the program blocks, basic operation, and download to PLC. So all the steps here also there. Okay. But mostly I take from their menu. All these are from their menu. You know how to do this. Some I create my own, then I screenshot and put it here. Okay. Later on you can copy this. So this one you see if you really choose. I mean, choose, I think must be go into the folder and save. Okay. I show you.
Google view. Okay, so you go to FP0R. FP0R dash C32 CD hardware menu. FPOR. This one is called beam rate. This one terminal blocks. Okay. So anything not you just ask me. Okay, because I know them, right? But chemical, right? Chemical will be very good on this. Okay. So we need to know the first pin is what, second pin is what. Okay. Then only we can know the input outputs. That's the most important thing. Okay. Slowly go down. I'll show you guys. No, I don't want this. I go make it smaller. Go down. Go down. Go down. Okay. No. The content. From the content we can go. Terminal layout. Okay, click terminal layout. 35. Okay, this one for the C10. Okay, go down. C16. Okay. Yes, wait. Okay, C60. Okay, this is how it looks. Can you see? It's a 2-pin drive. So X0, X1, X2, X3, and the pin. Go down. Go down. This one is the use Panasonic. Very, very rare. Not very, very rare. It's not for it's a new one. Very rare. That's why I only have two. Like that one and this one. The C16. Sorry, C14. So just I think only when Tuesday I get this. I ordered last week. So for the input, the last two is the common. So you can see, for input, the last two is the common, right? Okay. Then we see whether both are same. So for input, put here this side and later on let's do maybe do something like down output and output. We only use 6 parameters for the A. 6 output. Then 2 for the power supply. Positive, negative. Can you see the output side? None. Can you see? Positive, positive. The positive terminal as well as the negative terminal of the output circuit are connected internally. So we these two lah. So if you already give the positive negative for this you need to give.
What's that?
Yeah, only here the last two pin need to give the positive negative. The other one is already internally connected. There's something here I never found here. Okay. Because there's a space here. Okay. So if I find that this, so this is the x0, right? So it means x0, x1, you need to know X0 is what color, then only you can say it. Okay, so you take note of that. Normally what they do is they will have something like another connector here. Another connector here. They will connect to connector, then they will have a terminals. When I show you like this, cable to cable, then this one become a terminals. Then easy to connect. But for that one, that is a 10 one I don't have. 10 connector. You staying in Singapore?
Yeah, weekends I can stay in Johor Bahru.
Oh, weekends lah.
Weekends I stay.
From Chile.
Hometown is from Tempat.
Huh?
Hometown is from what?
Seremban.
Oh.
Okay, how we do? So now this one is the X0, right? So means this is X0 lah. So check the pin. So we check the continuity. Take one cable. Take one. Okay, touch this one. Okay, means there's a continuity left. Now you touch you see which color. Maybe either the brown or the black lah. Touch. This one. Okay, that's the black. So you take note. The black color is the S0. Then so this one is S1. Just the white color. Okay. So what? So you put this black, white, then grey. Yes, correct, yeah. Then this one is grey. Grey, then purple, then blue, then green, yellow, orange. Yes. So the last two is the that's the red. That's the brown. That's the red. So this one must be combined together lah. Just combine together. And this one all one by one. Okay. So you take note of that. Okay. Then this one also to be the same color. Yeah, okay. The output also will be the same color. Now, I have prepared a cable, then later you connect that. So, one X0, X1, X2, X3, X4, X5. We use empty X5 now. Okay, so these two no need to use. Okay, just cut it. Then these two I will combine together. Okay, then later you connect. From here you connect this connect here. Then from here you can connect to our lamps. Okay. This one will be, it means what? Which
From here to here.
yes, from here to here lah. Then from here to then our system, our terminals, not in our flow. So see in your panel? Never. But you know they're using this PLC lah.
They just showed to me in picture.
Maybe in your panel you can see the connector. Yes, it's now show you.
They using terminal code like this.
Like this. So it means they from like this lah. The ribbon cable go like this lah. Oh, okay. It's kind of normal terminal. And what I mean is from the PLC go to the yes, this the one. This the connector I see. So this is the the 10 pin 10.1 and the other pin go here, then you can tap from here. Similar to just now I showed you the
This one they use for the easy cable leading.
yeah. But that's how it should be. Normally they will do like this. Because for the to do the wiring right, it's tough job for them. How long would you work in this company? Just 2 months.
This one the UP Singapore government project. So my boss can claim everything from the sign up.
This is even it's not in your field, at least additional something lah.
Even my salary also they cover.
They cover.
My salary also.
They cover from the
Not paid by my company.
the project lah. Just try to understand what the thought. But later I will teach you lah why this one. Because with this one, in this thing I haven't do. I just we are just arranging the cables only. Later on we give the power supply there. Then I will teach you for this one supply and this one supply. You take your output. Output is same, but positive is a red color output. Red and alright. Alright, so we still Y0 what 0 to 5. Then last one is the common, right? You have to see what to connect. And same for this also. 0 to 5. So here, from 0 to 5. The last two is the positive negative. Right? Right? Okay. So this one, and this later, and the power supply also later. Okay. Madam, I will show you what is the one. Okay. Now ours is a C2 transistor. Okay. So you see here the input, right? Okay. Can you see at the comma, right? Okay. At the COM, you can connect positive. Can you see like the battery symbol, right? Okay, you can connect positive. Okay, you see, if you connect positive to the COM, the input must be input must be negative. Can you see? Okay, can you see, right? Show me. You will make it. See, if at the COM I connect positive, then my inputs must be positive, so negative. Can you see? What is negative? The opposite way always. Okay, but I will draw that one. Okay, so means at the COM negative, the input must be positive. You see? If at the COM is negative, right? If you connect the, because this one means it's all up. If you connect negative to the COM, my input must be positive. Okay, because it's right. Okay. For the output, you see, for the output will be positive. I'm going to find it positive, negative, negative. Then, so this is the negative, positive, go to the load. Okay. Then my output from here to here. So it means that my output is a 0 volt. Yes, it's a negative, negative. Okay. Why? Because you see, the positive side go to my load. My load means my output standby. Go and standby. So when this output is on, I might power up this, right? So normally load means we have positive, negative. So if already positive I connected, so my output is a negative. So that is the transistor output. Means transistor means our output is a 0 volt. Yes. Okay, I will show you. Ours is a C32CT. Oh, sorry. So it's not a C. Same thing. C32CT. Okay. Now, I will draw the wiring diagram. From here you can understand it. Okay. Now, so so you see, we have x0, x1, x2, x3. I just put 3, 4 here. Okay. Then we have a COM, right? Okay. Then we have a power supply, correct? Power supply. Right, this is a power supply, right? So, so means I have a power supply. So now in this one, here is the power supply. These two, can you see? 24, 0 volt. So the link here means all these three are connected. Got it? Means if you connect 124 here, all these can be 24 volt. If you connect 0 volt any of the terminal, all these 0. This one is like 1 by 1 only. Like 1 to 1 lah. Okay. So later you can take positive, negative, you can take positive here, you connect it. So means you are powering up this.
If I take out from here.
I mean just tap this one is already connected here. Okay, or you can do this way also. Okay, you can remove this, but take note like which one is the negative or the color. Or you can see from here also. You see? That's one more key. Now, so then you can take out this one direct connect here. And this one, you can later connect here also. Got it? 24 volt DC. So I can connect the positive to here, 24 volt. So all these become positive. Then I can connect the 0 volt here, negative. All these are negative. Then this one I can connect here to give the power to here. Okay, and here. So this is my power supply. So I do the power supply is this. Is that one. Okay. Now very simple. So you see, I have the input. This is my PLC input, right? This one is the terminal block just now we connected. Yes, okay. Then to the common. Okay. Now I have switches, right? Okay. I have the switch. Are all normally open switch now, okay? All the switches I already looked at the back. As you can see at the back of the panel, I mean this one. Yeah. At the back of this, see, all these I look. Okay. So the looping is, can you see, income, that is the looping. Okay. And same for the output also. Output also all I look. Yeah, because you see that. You see in the picture here, all the input, right? One side is loop, correct? One side is going to the PLC, same concept. So this is a switch. One side are loop, one side is going to PLC. So this looping, I connected like an input COM. For the output, I name it as an output COM. Then this one by one, right, is going to this input and this output. Got it? Okay. Now. So this I loop, then I connected to a terminal block. This terminal block I call as an incom. Sorry, no, that incom. Okay. Now, and now what you do very simple lah. From this you connect to the each input lah, right? So from this input to that input, right? So for the push button to the input. Now, the COM we connect the power supply. The incom also power supply. This incom, okay, COM means very simple, common. So a common signal. So this is common signal for the switches. All the 6 switches lah. Okay. This COM means this is a common for my input. Okay. Now, you see very simple. You see here, if the COM positive, right? So if the COM is 24 volt, this looping is the incom, right? The incom must be 0 volt, negative. Very simple. If this one is 0 volt, this one is 24 volt. Okay, why like this? Okay. This is your percentage, right? Why? Now, how it works, this is our PLC. Actually, inside the PLC, okay, inside the PLC, they have they call optocoupler. Optocoupler, okay. So that is something like this. So they have like a diode symbol. Okay. So like a lamp, right? So how it goes? So let's say I give 24 volt, right? So 24 go and stand by here. For example, so example is, let's say if we using this first, it means so I COM, so 24 is here positive. So the moment I give a 0 volt to the X3, right? Then only it will become 1. Okay, 1. So that's how it works. That's why it's always opposite. Your COM, your input, very simple. Let's say you see your input is positive, means your COM is 0 volt. Got it? Okay? If your input is 0 volt, your COM must be 24 volt. Very simple. Okay? So since I have multiple switches, so I just loop all the switches. Clear? Okay? Now the output. Actually output also same thing. Output same. Why is
Y0, Y1, Y2, Y3. Okay. So this each output I already have the lamp, right? And this is formula, right? So all the lamp I already looped, correct?
Correct.
Already looped. Then I go into they call outcome, right?
Yeah.
Okay. Then we have a power supply. So all the lamp loop cable connect where? Which one? You see, huh? All the lamp is connected to the positive, correct? So the outcome must connect to the 24 volt. Okay. Then then each lamp go to the this one like my what this one don't have com, right? Sorry. Okay. Each one going to the output, right? Then this one got positive, negative signal, right? No com, right? So this you take 0 volt, you connect it. Okay. Then the 24 volt you connect. 24 go to 24, 0 go to 0. Then the output com connect to 24. Why? Because you know why? Because my output here that is from the output to my lamp, right? Is a 0 volt. It's a transistor. Okay. It's a transistor means okay, this is a 0 volt. So to the lamp I need positive negative. So one side is 0 volt means the other side must be 24. So that's why the loop cable I connect to 24 volt. Okay, understand? Okay. So actually how it works, you know, inside here is like a lamp. So you at the COM you stand by the signal, you give the input. Okay, inside there like a lamp on. So if the lamp that's called optocoupler. That's the optocoupler will convert the value becomes 0 1. Okay. The same thing here. Here is how it works, you know, actually. If you see inside the what PLC in the back now, something because we know our output is 0, right? So we take the 0 here, then like a switch. Like a switch. So the moment from the program you on the output, so like a switch goes. So the 0 would go here. That's how the concept. So my PLC now is act like a switch to on and off my output. Okay, can do the wiring. Once you do the wiring, okay. So what we do first? This one very easy lah. This one very straightforward, right? This one output, this one input, very straightforward. Then this input com, output com, you see which one you want to use. So for the because input you can use both. And so you just decide what you follow that. Okay. Then you take this one, you remove this one, then you take one. I give you the cables. You take the positive, connect the positive. You take the negative, connect the negative. Okay. Then this one, right? Then this one, I put somewhere here lah. Then this cable later you connect it positive. Okay. Then done. So this one is done. Then this one is also done, right? Now here got COM, last one COM, right? So this COM, let's say you want to take 0 volt. Okay, for example, 0 the PLC COM, right? 0 volt, then you take 1 0 volt. Okay, fine. So this one last two is a positive negative, right? This one also take one positive, take one negative.
First one is the power to this one.
Yes, to power up this directly. Because why? I use like 3 terminal for input, 3 terminal for output, right? You see, these 2 meter 24 volt 0 plus minus. Then here got 1 pound. Here got plus minus. Then here also plus minus. So how many plus minus already? 3 or 4 plus minus already. So if directly I want to take from here to connect means not enough. So that's why from here I connect here. So that is 1 terminal and I make it like
5 terminals for positive, 5 terminals for negative. Like I expand the terminals, so like I just share it. Okay? Then if you need any cables, you can take from here. Okay? Don't worry. Do the wiring. Before I on, I will always check. Anything not clear, you can ask me. What access? Here the for this only this one can do. This one is already done.
understand, let me know.
I'm just confused with these two name.
Which two? The input com and output com.
Yeah.
Okay, good. So now first thing, this input the com, what do you connect? This that
I go to 0.
I mean you mean this com, right?
This com.
You mean this com, right? Now talking about this com. This com what you connect? You haven't connect. Okay. You decide first what you want to connect.
24.
Okay, let's say you want to connect this, right? So if the input com you want to connect 24, the in com you connect 0.
Max 0.
Yes. Just connect to the 0 volt, that's all. Okay? The one output don't have. So first you take 124, connect here first.
24.
Yes. 24 from there, you connect here first.
In another case.
Yes. You use a longer cables. Use this cable or long cable. All I do is reuse that all the cables. Use for projects, then I reuse that. Okay, good. Okay, now this one done already, yeah? Okay. So now this positive negative connected. Okay, you connect this positive negative. Then the outcome you connect to 24 volt. Yes.
But the outcome got two.
Why?
One is in one.
One is income, that is you already connected earlier. So
Income should be the
income, you using which one? Income 0 volt. This one you connect by. This one is positive, right? If this one positive, the income must be negative 0 volt. The opposite way. Okay. Then this com is fixed. Okay. It's 24 volt, right? So just connect to 24 volt. Okay. So finish. Now just plus minus. You connect one plus minus. Position also can, or this one can, or here also can. So it's not blue. Okay, okay. This is negative lah. So now this is positive. This com we connect what? Positive, right? So it means the input com must be negative, right? Okay, right. Okay. And this one must be positive. This is negative. Then output com must be 24. That's it. Okay. Let's say that you press this one, it's a wrong input, right? You just can change here. Okay. Now this is the input, right?
stop and push over. Because now program now just start on, stop off, right? It's true, now program.
So for start, when that's only the light will come on.
Doing this right here, right? Yeah. When there's an input, then only come out. No input.
This one is stay.
Stay like yes. Because it's always, the input is always on. This one is, when I press, it's on. Stay on. I release, it's off. Okay? That is because our output, according to the program, because the program we do the latching.
Okay.
That's why the output is different. Okay, good.
Can more time.
Can.
The power like from power supply, giving power to here.
Yes, correct.
So
When giving power to here, 24 and 0. Okay, yes.
then from here,
From here I give the signal to the input com and output com also.
okay.
Because input com and output com, that is loop cables. Right, the loop cables need the signal also. Right. So I can take from here. Positive, negative, like depend on how I do the wiring. Okay?
So this is the input lah. All this.
Yes.
This one you come in.
No. Because this input got two sides.
Two side. Okay.
Okay? One side I loop, I connect to the input com. The other side, one by one go here. Then this one by one I go to the input here. Right? This one. This one by one I'm going to the input. Because push button or any switches will have two terminals. One terminals I loop. Right? So the one terminal I already loop, I connect to the input com. Okay. The other terminal I need to connect to the input here.
Okay.
Right. So actually this cable actually directly can connect here also. Okay. Since we can do like this, right? That's why I connect here. Then from here to here, it's just a connector.
Double.
Instead of only supposed to be only one, I use two lah. That's why. So from here, this is my field device. From the field device, go to terminal block first. Actually from here, directly can go here. But since this is a ribbon cable, so from ribbon cable I go to terminal first, and this terminal to this terminal, one by one I connect. Same goes for your output also. For output, I have a loop cable, right? Loop cable I connect to the outcome. This outcome I connect to 24 volt. Okay. Then, so for this here, the last two pin is a positive negative, right? So I tap positive negative from here, I connect here. Okay. Then one by one, because this one is also got two terminals, right? One by one I go to here. From here I go to here. Then from here I go to the okay. Okay, got it? Actually, one enough already. Actually, this lamp directly can connect. This one only. Because I want to remove this, and I don't want to remove this. It's easier to do, you know. Flow means this one go here, right? Oh, mess. Actually, can also. Can. But the com, I need to additional for com everything. That's why I just put it like this. Okay, can understand?
For input, there is one com only.
Yes, one com.
But output it definitely should be negative and positive.
Yes, because you know why? Because the output, you give the signal. You need to give a power here. Then only this one can give you a voltage to light up. So
wait.
yes, so you means you give here, then only this guy can give you back. For input, no need power.
Just giving one signal.
Just one giving one signal, but there will be already one signal standby. That is your com. This one. This com is standby there. Then you just give one signal, one input here, then it can go to. So that's why this com here. So I just do, because there's a two com, right? So I just loop into one. Okay, good. Okay. So you can go for your break. Yeah, 1 hour.
1:30 I will send.
So you know here got
Restaurant.
two restaurants. And if you walk at the back there will be a mama shop also. Just opening recently. These two can lah, but expensive. Very expensive. One day you want to try can.
Okay.
But it's not the food expenses all you can claim, right?
Yeah. I leave my laptop.
Okay, sure. Because I'll be here.
Okay.
Mari makan. Mari makan. Okay. So we go to program. Go to your program. Open existing. Yes. Okay. So your day one. Okay. So again, that's all right. Okay. Okay. Now what we do? We add a timer. Okay. Click here. So in this one we call as a run. One run. One run. Okay. Right click here. Okay. Run. Okay. Because some PLC they call network. Okay. Insert network. Insert network. Okay. So, in one run, we can able to do only one single line program. It means that you can have multiple branch here, okay, multiple interlock, but it must be like go to the same one line. It cannot be two lines.
The output can be two.
Output can be many also, but somehow it's going to be one line. Okay. So for can I use this? So for example, I start then on our run. Okay. Then let's say like this. Close, standing, then the output of multiple, right? Something like this. So somehow it's going to be in, can be like this. So somehow we're going to pick up one line, right? So this is considered one now. So this
is considered another round. So must do another one. Okay, both cannot use in the one round. Okay, can? Okay. So it can be so many branches, output, input, so many branches can. But at the end, must be go back to the one line. Now, so we want to do timer. Okay. Put normally open. Yes. Then use the Y0. Enter. Okay. Then the output want to put timer. So timer TM, yes, this one. Timer. Okay, which timer? Okay, you bring the mouse here. This one is a 0.1 second. Go here is a 1 second timer. This one is 0.01 second timer. This one is a 1 millisecond timer. Okay, it means that this means okay. Let's see. First one is what TMX, right? Okay. TMX. So let's say I want to put 10 seconds, right? Means K means is a constant number. Okay. Then I need to put 100. So 100 multiply 0.1 second, I will get 10 seconds. Yes. So if I put TMY, because TMY is a 1 second timer, means 1 equal to 1 second, 1 unit. So just put 10 now. Okay, the other one TMR is what? 0.01 second. So I need to put K1000. Okay. Then if I put TML, because it's 1 millisecond lah, so I need to put K10,000. Because 10,000 millisecond is equal to 10 seconds. Because here is 0.1 second timer, this is 1 second timer, this is 0.01. This one actually 0.001 second. So if you multiply this, of course you will get this. So it depends lah. If you want to use normal timer, normally you can use this lah. If you need a timer below that 1 second, and you need a timer in milliseconds, then I use this timer. Okay. Let's say you want 1.5 seconds, then of course I can use this. So 1.5 seconds is 15. So we use TMY. Okay, so TMY, okay, what number? 0. Timer 0.
Oh, timer.
Yes, the timer number. 0, enter. Okay, what is the output? So K10. K is the constant number. Enter. Okay, that's all. Okay. You go to convert. You convert first. Convert PB here. So you automatically go at the end. That's supposed to be going. Okay, goes. Okay. So what happens is I start the motor on. When the motor on, I energize the timer. 10 seconds. Okay, 10 second timer. So after 10 seconds, I want to off my motor. Example lah. So you put it here, normally close. So you add normally open first. Then you put yes. Then what? X2. No. Because timer 0, right? So T0. Yes. So no need TMY or something. So T. Because timer got many types, right? So just use the T0. So means this means is the output of the timer. So how the timer works? Very simple. Whenever the input is, this is the input lah. Whenever the input is on, I start to count. Once I reach my set point, this is set point. Once I reach point, I give you the output. The output is the T0. So I put normally close because initially the T0 is off one. So when after 10 seconds it will on. So if I put normally close, after 10 seconds on means it's open. Okay? Okay. You convert, then you download to the PLC. press start. Okay. You press start.
Oh.
Yes. Okay.
The stop is always closed.
Which one?
The S one.
It's not always closed, means I'm using normally closed. So there's no input yet. So it's normally closed. If there's you give the input, then I open. You press the button, the second button. Yes. So this one, I know this one I'm a bit confused to understand first. Normally open, normally close. Okay, very simple. Normally open means it's a normally open. So from where it become normally closed or normally, I mean close or open, right? From the value of your address. So value of your address means, okay, x0 is what? Is a bit. 1 bit, right? It's a digital input, right? Okay. So at the same time we call it as a boolean. Boolean means 1 or 0. Okay. So if I put normally open. So when it's 0, normally open. When it's 1, close. The same thing for normally close. So when it's 0, normally close. When it's 1, opposite. So we need to know. So whenever if you want to put normally open or normally close, you need to know that what is the value first. Whether it is in normal state is 0 or it is 1. Because sometimes, because all my push button here is normally open push button. Means when I press, then only the input go to the PLC. Some push button is a normally closed push button. Means the input will be always 1. When I press, then only the input becomes 0. In that case, opposite. So actually both the X0 and X1, both the switch are same. Yeah. When I press, then only the input on. And I release the input off, right? But you see, for X0, I'm using as a normally open, X1 as a normally close. Why? Because X0 I use normally open because when I press, I want to energize the output. So I use normally open. So normally it's open, when you press, then only it close. Okay. Now, why the X1 I'm using as a normally close? Because I want to cut off the motor. So normally it's already off. The push button is off. So normally it's closed. So when the input on, then only I will open. So this one need to understand. You need to practice lah. Just a matter of practice.
So meaning, since you are using all normally open switches, it's become open and closed. If let's say you use always close for all switches, terbagi lah.
Yes.
That
The
one-
start will be closed, the stop will be open.
So it depends on the
Switches, yes. Depends on switches and also here in the program. How you want to use. Whether you want to, like this, very simple. This one I'm using normally open because I want to energize the signal. This one I put normally closed because I want to cut off the signal. That's all. Okay? Okay. So the T0, actually you press again the start. Okay, so you can't see the T0 is on, right? Because it's very fast. Why? Because you see, when I start, motor on, okay, I latch, right? So the current will go through here, right? Then the same current just give the signal to the timer to start. Okay. Timer will start to run. Once you reach the 10 second, the T0 so become 1. Means open. It's open, so the moment it open, what happens? The motor will off, right? This motor off, so the latch also off, and here also off. Right? So when this one off, your timer no input ready. So timer will reset. So when timer reset, your T0 will go back to 0. So
be the T0 should be off and on back.
Yes. So very simple. After timer, the T0 is become 1. So I open. Once the timer reset, the T0 become 0. So I close back. Since the process is very fast, you cannot see. That's all. Very simple. Okay? Okay? But if I take out this, then I can see that. If I remove that, you can
Yes,
see.
X1.
No, if you remove this one,
Okay.
then you can see the T0 on. Okay, you go to offline. Go offline, switch to offline. Okay, you take out the T0 here. Delete. Okay. If you want to draw a line, right, you can use this, or you can use the control and arrow. Also can. Okay. Now you put the T0 here. Normally open. Normally open. T0. Okay. Then you put one output. Yes. Y1. Okay. You convert, download, then you access. Can you see? On right, the timer.
Yeah.
You press stop. Press stop.
Here.
No, no, stop here. This stop. You press stop in the push button. Yes. So you see, when you press stop, the motor off, right? So when the motor off, timer reset.
Okay.
So the T0 also off. You try again. Right? So just now the T0 we use here normally close, so it's very fast, so we cannot see the T0 anymore. So this is how we will. Actually, if you want to learn some functions, right, like a timer function, some output, this is how you learn. You just put one input, or if you don't want to put this, you just put one X. Any X, just can put. Okay, you can do simulation also. Okay, go offline. Go offline. Go to debug. Last one, simulation. Yep. Now simulation, right? So now it's an online simulation, right? Your PLC is not on. Okay. You double click here. On. PLC on. Right? So you manually need to off lah. Need to off.
It is.
No, the start button. You need to on and off again because it's a push button, right? Then you press the stop, same thing. You double click, you on, you double click again, you off. Yes, because it's a push button. I press, I on, I release. So when you are doing testing, you learn yourself, right? So when you are doing testing, this is how you need to test. So better always when you do simulation, like better to put name like start TD push button, so you know that okay, this button must be on and off.
On and off.
Like a push button, right? You press the signal on, release the signal off, right? So when you testing simulation, you need to test the same way.
So meaning if I on also, I on first.
Then off the button. Yes.
Okay.
So you need to do this way if you are doing simulation.
For push button lah.
For push button lah especially because that's how the push button works, right? If no, then your program, won't run properly because why? When you design the logic, right? Because why we put the latch? Because the start button is a push button. That's why I do the latch, right? So means when you do program as the start button is a push button. But when you do testing time, if you didn't test the same way like a push button, then your program won't run properly.
If let's say it's just an on-off button, we no need to program the latching.
Yes,
One line only.
Yes. So let's say this is a button, like I press on and off. Let's say this is the selector switch, right?
Okay.
I on, the motor on, when I off, motor off. Then I only need to do the latching. Okay, good.
Okay.
Now you go to debug again. Simulation off. Okay, now I put the T0 here. Normally close T0. No, T0. Normally close T0. Yeah. Not. Okay, not. Normally close. Okay, and then. Alright. So means I start motor on like normal. So after 10 seconds the motor off. Then I on another motor. Okay. So you see. Okay, let's say you go to Y0 here. Enter. Motor 2, the name. 2. Yes. The first one changed to motor 1. Okay. Now you see. Start motor on, then motor, okay, then after timer the first motor cut off, then I want to use the same timer on the second motor. Okay, right. But now earlier we didn't do the latching, right? Because why? Because the timer was like always on. Correct. But now the timer is like on off. Correct or not? Because why? After the timer, I cut off the motor 1. So if the motor 1 is already off, so the T0 whatever, T0 after 10 seconds on, off back. Correct or not? So it means this T0 now is similar like your push button. Correct. So you need to latch it. Okay. If you didn't get the idea, never mind. You convert, you download first. You don't do latch. If you didn't, okay, very simple. When you do programming, right, sometimes you need to imagine. Okay. Before we do something like in latching all that. If you cannot imagine, no worry. Just whatever you done, just download and test. Then you can know really what happened. Why I need to latch everything. What happened?
Motor 2 didn't start.
Just start like. But we know the T0 actually is already on and off.
Yeah.
That's why the motor is off, right? So we know the T0 actually is already energized. But the Y1 is cannot be on because this one is too short the timing. On and off, right? So what I need to do? I need to latch. Y1. Latching means always the output. Enter. Okay. Control up. Yes.
you try. Convert. Yes.
So you see the converter no need to download actually. You know why? Because just now you edit this one when it's online.
Oh.
So when you edit when it's online, what happens is because just now all we offline. Means we disconnect the communication, do the program, then we download. So just now you add this one is I'm still on my communication. So I do go do editing. After edit, when I convert, it will automatically transfer the file here.
Okay.
Yes. So no need to download again. So that is called online edit.
Online edit.
There's two types. One is the online edit, one is the offline edit.
So if do offline, download again.
Yeah, if you do offline, need to download. If you do online, you need to download. Once when you convert, it will show the message to download. Okay, now I show you.
Download to PLC means
When it's offline.
offline. So if we download the one will go to here.
Yes. Okay, now you press that. Okay. Now let's say so this one is still running, right? So let's say I want to put a stop button. Okay. But I don't want to offline. So I want to do when it's online, right? Okay. Put it here, normally close. Same stop button, X point. Enter. Okay, convert. Okay, wait. The changed program will be transferred to the PLC connect. Okay, yes. That's all. Now you press stop. Yes. You start again, press enter. Okay, good.
If I didn't put the T0 on the top first run, then when I press X1, the both motor will be shut down.
Because why if you didn't put here means the motor one will be still on. Then the second motor one. Okay, good. Now, so just continue what we do here. So let's say now we have the start. Stop two button, right? Okay. Then we have Moto 1, Moto 2, Moto 3, right? Okay. So the Moto 1, okay, it's run for 10 seconds, right? Then after that, Moto 1 off, Moto 2 on, correct? Okay. So until here we already done. Okay, now what I want you to just continue. Just be familiar with the software. So Moto 2 run for 12 seconds, then Moto 2 off, Moto 3 on, run for 10 seconds. I mean the timer, I don't care, any timer can. Okay. Then after 10 seconds, Moto 3 off. Then if I press stop, all the motor off. Okay, you try this. Try to do motor 2, then you test. Okay, now for this, you don't do online edit. Yes. Always practice offline. You know that is the safest way. You know why? Because sometimes, because online, you see, when you do online edits, when you do some changes, so when you convert, straight away you go and download. Right. So the moment you convert, straight away transfer to the PLC. Okay, which is for beginner level is not safe. You know why? Because sometimes we don't know whether the logic we do is correct or not. So the best way is go offline. Go offline, do the logic, convert, then you see first whether it's okay or not, then you transfer. That is the best way. So you always do the offline edit, then online, then download. You do that way. Once you are familiar with that one, then you can do online. command list and intros. If you want to open, you can open from here lah, right? Then you go to make it smaller a bit. Okay, I just need device enough. Okay, put the device here, T0. Okay, then you know, run T0 lah. Wait, if I want to use timer, actually I can choose here, data tag. Okay, so if I want to see the timer value and timer running, right? I want to see the timer running. That is this EV. Yep. Yes. EV0. Okay. If you press that, double click it. Timer elapsed value. Click here. Okay, this one is a different timer value. I want to monitor Y0. Okay. Then Y1, Y2. Okay. Monitor stop. Okay, right click here. Why monitor stop? Okay, go here. Click here. No, this one is an error. Status. Go to online. Device monitor. Okay, start monitor. Monitoring execute. I think just now that's why then you put EV0. EV0. Yes. Okay. Okay, now you press that. You see EV0 means the first timer, the running value. Okay. Then here I can see 1 or 0. The output. Yes, because output is a bit, but just you can show 1 or 0 lah. Okay. The EV is 16 bit. You see? So it means it can show values. Yes.
So if I put EV2, timer 2.
Yes, correct. You can add EV1 and EV2. Good. Okay. All right. Save first. Okay. So this one we call as the device monitor, or common name is variable table. You can call it as a variable table or watch table. Depend on the brand. Some brand they call watch tables, some brand they call tag table, someone we call watch variable table, all that. But very simple, device monitor. Okay, why device, right? Okay, like it's a similar like Mitsubishi. Okay, they call this addressing, right? All this addressing actually they call as a device. Yes. So they call as a device. So that's why it's a device monitor. Status display is, you click the status display, that is the your PLC status. So if you have any error or something, it will show you the error. So it can show you the error down here. So now no error, right? Okay. So now it's in run mode. Okay. Program size is a 32K step. Okay. 32K step means this one. The 5, 10, 15, 20, right? These are the steps. Means very simple. See, this is 0, right? Starting with 0, right? Means 0, 1, 2, 3, 4. So 5. Close this. So this is 5, right? So next is 10, right? Means inside here is 6, 7, 8, 9. Got 4 data for the time. Because why? Because why 4 data for time? Because you see here, this is 0, right? 0. So each one is like 1 data, right? 1 step, 2, 3, 4, 0, 1, 2, 3, 4. That's all. Next is 5, right? This is 5. So this one must be 6, 7, 8, 9. Then only the 10. So why 6, 9? So this one using 3 steps. Why? Because timer input, because this is the input. Timer address, the D0. Timer value, which is K10. Then timer output. So inside here got 4 steps. Yes, one is the input, one is the timer address, another one is the timer value, and the timer output. Got 4 steps. That's why next one is a 10, right? So 10, 11, 12, 13, 14, 15. Same thing here. 16, 17, 18, 19. Go down. So it's the same thing. So next one you start, you will be what? So 25, right? 25 means 26, 7, 8, 9. So next step is 30. So total go up to 32K steps maximum for this PLC. Okay, good. Now, okay, go offline. Okay, go to system register here. Double click. Okay. Then here is you can put the settings here. Okay. You go. Okay. Hold and on hold. Okay. See, counter starting address is 1008. Okay. Go to next. Action of error. So. So this is stopping the PLC lah, right? Stop when the error. Okay, go to time setting. So this one is the time setting for constant scan. Okay, they use 0.0 milliseconds. Means they using microseconds. Okay, so constant scan means scanning the PLC. So how the PLC work is, it will from left to scan to right, then from bottom to, from the top from the bottom. Okay, that's how the PLC scan the program. So means every normal is the zero lah value, right? So means it is in millisecond lah, right? So very fast it scan. Okay, that's why just now the T0 we cannot see it's on, because the movement is on, okay, straight away cut off the time. So very fast. That is the scanning time lah. Okay, this is the link word. Now, okay, go to this one, controller setting. Yes, this is for if you are using encoder. Encoder means yeah, I have that. So encoder means this one can show you the rotation RPM. Okay, so this is not motor, this is the motor, right? So this is the motor. This one normally will be attached to the shaft. Okay, why? Because it can show you the correct position. So what happened here? Because every time rotate right, so it will give you a signal. Very high speed counter. You know why? Because inside here they have like a disc. Okay, then they will have a small hole. So they will have a laser here. So it will just rotate a little bit. So from one hole to one hole, right? Okay, it will count one. So one complete rotation is depend on the encoder lah. But this encoder didn't write down what is the setting because need to check the manual. But normally the encoder will give you like 3000 resolution per minute. Means one rotation you will have 3000 value 3000. So if to count that, I need a high speed counter. Correct? Because means if one rotation is 3000 means you know how speed to count 1, 2, 3, 4, 3000. So if I'm using encoder and I connect to your PLC, I need to enable this. So now if I want to X0, I want to use as the first high speed counter. So I need to set here. Okay, got it? If no, it will be like normal input. Because normal input cannot count high speed. Because there will be a delay, timing, a small timing difference lah. So cannot. If I didn't, let's say, if I didn't enable this and I connect this and I take the output from here, go to the X0 example lah, then I'm using a normal counter. If I rotate like this, right, I won't get a value. Normally lah. Because why? Because this one we call as what? It's a induction motor. Okay, normal like AC motor. Okay, it's controlled by a VFD, a drive, right? Okay. Now normally these drives can control the motor speed. Okay, how fast you want to on the rotation, and rotation direction and the speed can control. But it cannot give you like correct position. Where are you? Where am I? Because let's say it's carrying a device, right? So it cannot show you where I am the position. So to get the correct positions, I can use this. Then, so let's say this one is connected to have you seen a crane? Right, they have like the port, right? They have a crane. This one is move, right? The moving, who control the moving? These motors. But how they know the position? They use the encoder. Or they will put a sensor lah. So when they press extend, go until the end, there will be a sensor to cut off the motor. Then if you put retract, then go retract, then cut off. Or you can use an encoder to know the position.
So let's say you want to move until here 10
Yes. 10 rotations. So 10 rotations. So one rotation is 3,000. 10 rotation is 30,000. So you key in 30,000, you can move. So motor will key in 30,000. Motor can move normally, but this one keep on giving value. Okay, one rotation right 3,000. Then until go to 30,000, again I cut off. So I take the output, I cut off the motor. For that we use the encoder. Okay. There is another one. Go to next. Yes, this one is like, can you see? Pulse. Yes. Pulse means, just now this one go to the input. Okay. Pulse means from the PLC output go to my servo driver. This one. Servo or stepper driver. Yes. This one. Okay. So you see the output go to, actually I connect to here and from here is to here. So means my output, okay, like this one is a motor, this one is a motor, right? Okay. You see two type of motors. So this one we call induction motors. Induction motors normally for high load, like high load and everything. Okay. This one we call stepper motor. Okay, stepper motor. Stepper motor means what they have like for positions. For correct position, they will stop. Okay. Now, so how the stepper motor work? Okay. How this motor works? Okay. Here we can set the speed. My PLC just send the on signal, can on. Just a digital one. Okay. Or another way is my PLC can on and off. At the same time, my PLC can do the speed setting using digital. The hertz, you can control the hertz, but how? The analog. Like the one you see, like the analog. So from the PLC, digital signal go here to on and off the rotation. Analog signal goes here to for the increase and decrease the speed.
For analog and digital, I understand we do the programming on and off.
For analog means the analog we send value. We haven't done, of course. So we send value, voltage value to here. So when this one, okay, let's say they say the analog signal for this is let's say 0 to 10 volt. So from the PLC, the analog output I need to program. So I will send 10 volt over here. So when this one get 10 volt, this one rotate to 50 hertz. So let's say I program to 5 volt means half. Then when the 5 volt come in, the motor rotate only half. 25 hertz.
Programming for analog also similar like this one.
Similar like this, but more to values, more to calculation, more to values. This one is just on and off. For that, we need to use more data register. Yes. Okay. So that's how this motor works. So two signal. One is digital, one is analog. For this one, how this one rotates is just a digital signal. So one is the pulse, one is the direction. So the pulse is already programmed. This was stepper motor lah. So how it goes is direction is just forward level. The pulse is how fast the pulse output on off like that. Okay. That's not in your program. We see right, there's one pulse function. Right? That is the normal 1 second pulse lah. But we need to enable this. Create a program means very fast it will pulse in milliseconds. So if you want to run faster, the pulse will be, so you need to do the programming lah. You need to set what is the speed. Okay. This output go to here will be like very fast pulse. If the pulse is fast, it will move very fast. If the pulse is slow, it will move very slow.
You mean the signal from here to here?
Yes. And at the same time, the pulse is, you need to tell number of pulse. So what happens? You need to tell number of pulse and the speed. So if you put two value, there will be a function for that block. So when you put two value, it will automatically calculate and control your output. So let's say I need to move from here to here. Let's say you need 10,000 pulses. So okay, if you send 10,000 pulses, but how fast it send, how slow it send, depend on the speed. Let's say you put 10,000 pulse, but the speed is slow. So means The 10,000 pulses are one by one, 1, 2, 3, is slow. So the motor will move slow. If the distance is still 10,000, but I want fast, means the 10,000, the pulse is very fast, 1, 2, 3, 4, 5, 6, 7. So it will move fast. So for that, they use the pulse function. So if you want to do pulse function, you need to set this. Then only my PLC know my Y0 is the pulse, Y1 is the direction. So the Y0, okay, you need to know which terminal is the pulse. Okay, Y0 to the pulse. Then Y1 is the what? The direction, right? Then you need to know which terminal is the direction. Okay, connect that. Then you can control it. That is the pulse function. If no, it will be a normal output. Cannot produce pulse output. Because the pulse is very fast. If not mistaken, it will be 10,000 pulses per second. 100,000 pulses per second to produce something like that.
So this one is only for the special precise process.
Yes, so if you are controlling servo motor or stepper motor, controlling, need to use pulse output. So if you want to get a motor position, encoder value, then just now high speed counter, that is the encoder value.
Because the normal PLC, let's say I control here from HMI, off about few seconds, then leave off.
Yeah,
That's the reason.
that's a normal lah. Yes. But is it take 2 seconds to off or immediately off? Your system, I mean the HMI is not.
Last time, previous company, if let's say I off, normally the valve is nearer, should be faster. Sometimes the pump, like pneumatic pump, 30 delay, 1 second.
Yeah. Some delay, of course. This one because need to send a signal to the solenoid, then the solenoid will do the work, right? Yes, of course. But the PLC will give the value signal already. But your instrument to run, that is what will be slow a little bit. Okay, good. Any question? This what? Encoder and this one is motors. So understand the concept. So when you have time, then you can just explore this. Next time you can come for advanced training. So advanced training where you can cover the analog, because this training don't cover analog. So you can cover analog, the pulse, servo motor, and the encoders. But depend lah, if your project they using that, then you can come for that. Your project, because I see your project mostly just use normally open, just input, output, I mean just on off, set reset, timer, that's all. Mostly.
For this project, the accuracy is only on the amount of water transfer. They need very little more, like 10 mm. That's the only precise one. Other than that, all just
Normal. Okay. So how they control the 10 mm?
they're using the timer. 10 seconds,
Okay.
cut off, then the 10 mm.
Oh, okay.
They do some modification on the
And on the instrument itself lah.
overflow
Okay.
it more than 10 mm.
Or more than damage will overflow. Then I don't need the flow meter all lah. Because then if more precise, then you need the flow meter, everything. Because when that one will be expensive lah when you do that all. Okay. Then you go to next. This one is a PLC setting. This one is for pulse catch input setting. This one is for the what? How to say? Interrupt input settings. Okay, this one when you enable the settings, this settings, right? Means if there is a interrupt, means like the input on, then suddenly the signal like lost at 1 again, but in very fast. So it can get the interrupt signal. So I can use that signal to do an alarm or everything. So, but you need to enable which one you want to use. Okay, go to next. Okay, this one same thing lah, effective. Okay, go to the next. Time constant setting. Okay, this is normal lah. So how fast the scan rate lah. Okay, 1 millisecond is okay, it's normal. Okay, setting 2. So oh, okay, the other lah, right? Okay, another 8. For the toolbox setting, go to comport setting. Okay, the toolbox is the USB port. Okay, no, you go to portrait. Toolbox. Because when you connect both will show in the in PLC both will show the COM port only. The USB port they call tool port. The round pin, right? Round pin they call COM port. This one you can cancel it. Okay, now create new project. Just save this. FP0-C14. This is US monitor controls. Want to open, go to IO command list. Okay, X, yeah, you put start, same start stop, and the output is motor 1, motor 2, motor 3. Now you put normally open, X0. Okay. Then the output I want to use set. Sorry, set. Okay, Y0. So what is set actually? Normal coil, this is the we call coil, right? The output. Okay. Normal coil, it is like when the line is on, the coil will be on. When the line is off, the coil will be off. Okay. But set means I just give one pulse enough. Okay, just like one push enough. The set always will be energized. Okay, it will always, so no need to do the latching here. So if I want to off this, I cannot cut off the line. I need to reset it. Yes. So to reset, okay, I put another button. X1. Normally open X1. Okay, then reset the same Y0. So now you see both the buttons are same, right? Because why? Because when I press, I want to energize the line. Here also same. When I press, I want to energize the line. So that's why the X1 here is normally open now. Earlier normally closed, right? Because when I press, I want to cut off the line. Here I want to energize the line. Okay. Set, reset. Okay. You convert first. Okay, close. Then you save first. Day 1, assignment 2. Assignment 2 or lesson 2 and no problem. Make sure you understand. Okay, then is download. Okay, then online monitor. Okay, now you press start. You see, output on, right? You see? So just always reset until I press reset. Press reset.
If I press start also, the reset button.
No, okay. It's not the reset is changing color. It's the color indicate is for your Y0. Yes. Not function. So this one we call functions. Okay. The set, reset, the timer, all that we call it as a function. Okay. So the color is for the output, not your function. Okay, good.
So instead of latch and the not symbol, we straight away can use this one.
Yes. So your program they're using both, right? So use the normal output also use. So it depends on the situation. Okay. Now for this, if I want to use timer, how? Okay, you go offline. Okay, you put the Y0 here. Normally open Y0. Yes. Y0, yes. Then you put a timer 10 seconds. TM1. TM0, yes. Enter. Then so now I want to reset. I don't know whether try put here reset. I want to see reset Y0. Okay, now you convert and see whether I can use that. No, okay. So I can use. It's not necessary must be at the output. Okay. So X0, Y0, X1, okay, Y0. Then I reset the Y0.
So even you didn't press the stop button, after that second the motor will
Yes, reset. So I have to reset lah. So set always one place. Yes, this is the one. Okay. Set of output only one place. Means okay. So let's say I start. Then I have a coil, right? This is called coil output. Okay. Let's say motor. So I do the process, everything. Let's say I attach. Then I do some process. Then suddenly, okay. Then I have I have something to off, example. Then I have suddenly okay sensor. One is on. Then I want to on back the motor. Right? Because sometimes I start it's run, then it off, then example valve open, then it close, and after some time the valve open again. So it means you cannot do like this. Two coil, two output cannot. Okay, because why? Okay, you treat this as a, but if you do a proper program, it can work. Okay, here also later we can try. See, coil means it's a relay. Okay, so let's say I have one valve. How many relay I will have to control? Only one, right? Okay, so you cannot have another relay that is going to the same valve. Cannot. So whoever want to control the relay must go to the relay only. Right? Same concept. If let's say that I have another sensor, want to on back the motor, I use here. I should call OR function. OR, okay? OR. Put it here. If something want to close the motor, can put it here. Okay? So you can do like this. Okay, we'll have a conflict.
If one full set of programming, you can have one output only, one time only.
Yes. So if using this, if using set, it's a set. So if using set means it's just a set. Reset multiple times you can. So reset means just on off the output level.
So if let's say I using set, reset, and then set, reset again
For the same output.
Yes.
Cannot. You mean okay, set Y0, then reset, right? Reset Y0. So if you want to set again, cannot set the Y0 again. So must use here.
Same like
Same. Or at the same time you cannot use the coil also. Will have a conflict. Because this one, the function of set is to energize the Y0. This function of output also energize to Y0. Okay? So it means if you're using set or output for one output, only one set, or one column. That's all. Okay. But okay, you go down. Next line, you put normally open, just put normally open. Just put X2, sorry, X3. Okay. Then you set. Again, you put set Y0. Okay. Convert. No error, right? Maybe we see how it works out. Okay. But if you do this in Omron, it will show duplicate output. It won't give you error, but it will give you warning. Duplicate output means output using 2 times. Same thing for elaborate also. They will come up, but it's not error, they give you warning. Warning means it can download, but only thing is it won't work properly. Like if you didn't do a proper program, it won't work properly. Okay? Now, like Siemens all, no message, nothing. Means it's not like you cannot do. You can do. Like I said, that's alright. You can do, but you need to do a proper program. Then it can work. Okay, I show you here. Okay. Now, I'm using a additional the selector switch, right? Because X0, 1, 2 I'm not using. So the first switch to on back the Y0, right?
Yeah.
Okay, set. Okay, you download this. Okay. Monitor it. You press start. Can work, right? You on the X3 button. X3 is the switch. On off back. Because I'm using a set one. Okay, can go right. Now you go offline. I mean offline. Okay. The set Y0 you pick up, you delete. Put normal coil Y0. Coil. Y0. Okay. Now you convert this and because set means I can set also, correct? Again I can set, no problem. Because I send one signal set. Okay. Now you press start. Why? Okay, I will tell you first this one. Okay, why this one can work. Okay, so you put X0, X1, X3, right? The timer will get okay. How the PLC work? Okay, when you press this button, the PLC come and scan here. Okay, set. Right. Okay. So it will set the output. Then when PLC come here, nothing will do. When the PLC come here, nothing will do because you are already do set. So using set means it's already the internal latching. Okay. But if you're using coil, so what happened? When I press start, my PLC come here and see, okay, it's need to set. So actually inside the PLC actually set. Then when my PLC go here, okay, nothing happened. When my PLC go here, he will check X3 not yet on, right? So it will off the Y0. So actually it means when you press the X0 here, when you press X0, actually it's on. Okay. But the moment PLC okay, finish scanning, go to here, then you cut off the Y0. Because Y0, I mean this coil, how it works? When this one on, then only is on what? Correct. But if this one not on, so it cannot on. So PLC here on, here off. But it's very fast scaling.
If let's say I press X3
and X0. No, you press X3 and see. You want X3? X3 can work. Because why? Because I on this one, I on. So when PLC come here, because it's a set one, so you don't care. Okay, you off. Now you press start. You press and hold. Nothing. Okay. Now what you do? You do this latch the Y0. You go offline. download. Right to PLC. Because when you online, it will show mismatch. It's not right. Because why mismatch? Because the program here actually is not same. If you haven't downloaded it. Okay, now you press the start. Now the motor can go. Why? You know why? Because the moment I press the start, here set, correct? And here set, what happened? This one on already. This one haven't on yet. This one on already. Then my PLC go here, okay, nothing. My PLC go here and see this one is on, right? So it will analyze this. That's right. Now the motor can on. Earlier when you don't have this, motor cannot.
What does it if the PLC is coming from the top to bottom?
Yeah, it keep on running, but keep on scaling. Okay. Yeah, maybe I will do this. Just the color here. Start. Okay. Then set Y0, right? Okay. The reset we don't get, okay. Then so this is the X3, right? X3. Then the output Y0. This one is X0. Now what happened? So when the PLC on, right? PLC, right? So on, okay. This one is energized, okay, on. Then it's already on. Actually, according to the theory, it's already on then. Then my PLC go here, go here, go here, and come here. I see it's not on. So what happened? It will off the Y0. So means physically here on already. Here I off already. Then because this is a push button, why? So I already off one. So it off. So even though I still keep on pressing, keep on press, right? Okay, means so whenever my PLC come to this position, it will energize the output. Then whenever my PLC go to this position, it will cut off the output. But physically we cannot see because it's very fast. Yes. But you see, the moment I do the latching here, then can work ready. Correct.
Yeah.
But before that, if I on this one, then it can run. Correct. Because why? Y0 on. Here I'm using set one. Means it's always can on. Because somehow this one is like always on. But the moment I do this Y0 here, can work. Why? Because the moment it's on, I energize here. It means here on already. It's not here on the here on. That's all. The signal haven't go here yet. But then it's not off already because the push right. Okay. And PLC come and see here. Okay. Now it gives the signal. That is the reason. That's why I say. That's why it didn't give you warning, because you can do like this. It's not like you cannot do. Because I've seen some YouTube videos. They say this is a wrong program. That's not what they say. It's not a wrong program. If you didn't do a proper program, then it cannot work. Because sometimes what you think, because this is a selector switch, right? No need to latch one. Push button I want to latch, okay. But this is selector switch, no need to latch. So the best way is only use one line. This also can go, can go. But the best way is using one line. So X0 want to set this, okay. X3 want to set. Or if the X3 is a push button, it's a selector switch. So I want to do some interlocking. No problem. X3, then you do some interlocks. Then you put R0. Then use the R0 here to energize on back the motor. Something like that. Okay. Why you cannot do like two like this? This also can work, right? If I put like this, can work, huh? Why? Let's say put some stop, okay? Why? What is the problem? If like this means it can work, right? But what is the problem is difficult to troubleshoot. You know why? Because when how we troubleshoot? We troubleshoot from the output. Okay, it means if the motor is not working, so we go to the motor and check, okay, why not working? Whether this signal is already cut off or not, or this signal, or if the sensor is not on or what. So we do like they call reverse engineering. Okay, so from the output we check. Now open this program. So now so now the motor is the problem. I am using the motor at two places. So now I don't know where it will be the issue. So troubleshooting will be difficult. Whether I want to see this condition, this interlocks or this interlocks. Because our program not like simple like this. So because the motor on is not actually from the start. They put some relay 30. So this internal relay from where? From the top program. Then from top program also, it's not like straight away one input. It will be another relay. Then we need to search and search and search. So that's why we normally programmer they don't do this. For them also it's a tough. Because if like this we sometimes cannot imagine whether this one will have a conflict or not. Cannot imagine. So best way is doing this one. Or like what your programmer just now the program did, they just use not motor. They just use some relay 40, relay 41. Then later on, next time because so many interlocks, right? Later on you can do they do the list. Relay 40 or relay 41 is on, then only the Y0 on. You can do something else. If so many interlocks. I have done some programming like this because if so many interlocks, sometimes I also confused. So many interlocks for me also troubleshoot difficult. So what I do? Some interlock, okay, because for first process these are the interlocks. I put one relay. Then for second process, okay. So both this process, let's say need to control one valve. So I put it. So when this process is running, then this one will energize the valve. When this process is running, this one will energize the valve. For example, like
So for the R14, right? In the real physically also, if there is a relay, the same thing is the R14 also, right?
yeah. But we don't need R40. I mean, you don't need relay, but physically. You mean the physical relay? No. Physical relay normally connect to your output. Yes. Because why they use relay? Because something like this. Now our output is right. What is the voltage of our output? It's a 0 volt. Right. Our output is 0 volt, right? Let's say my device there is a valve. Let's say it's a solenoid valve. Is a AC 24. For example, AC 24 volt. So my PLC directly cannot connect. Right. So my output connect to a relay. From the relay I connect to a valve. So the relay is not this, it's just an internal memory. Okay. So here we connect the relay. So let's say this relay you name it as a valve, right? So V2 for example. So this one, so your Y0 will connect to a the relay will have a positive negative, correct? Positive negative. This is the coil, right? Your Y0 go to the relay coil. And this one is from the power supply.
So if let's say the instrument, the output instrument can accept 0 to 24, we don't need the relay
Yes, correct.
directly from the PLC.
Directly from the So it means if the instruments can support the PLC output range value, then I can use that lamp lah, right? This lamp can connect 24 volt, 0 or 24 volt. Okay, so I don't need a relay. So if my instrument need a different voltage or higher amp, then I use a relay. Even though it's a 24 volt, but the amp is high, so I cannot use this, right? Because my amp is low, because I'm using this small power supply. So because this power supply need to power up the PLC, need to power up the input output everything. So it's not enough to power up the instrument. So in that case, I use another power supply for the instrument. So for that I use a relay.
So the power supply will supply the power to the instrument, and then the signal only comes from the PLC to the relay.
Yes. So it means it be like this lah. So let's say I have one power supply, right? Okay. So the power supply negative go here. Okay. Then this is the output, right? So the positive, negative, okay, go to my positive, negative of my output lah. That's all. So my PLC job is to activate the relay. Then the same, let's say relay 1, right? So the relay 1 will have a open and close contact, right? This one will be from another power supply. Let's say the positive, okay, I connect here. Then this one go to the instrument. Then the negative, I connect here. This is the load lah, right? So these two different power supplies. Because let's say the watt is higher here. Let's say this power supply is just 1.5 amp only, for example. Because I'm using the same power supply to power up my PLC. So PLC maybe let's say use 0.5 amp, for example. So I balance will have only 1 amp. Actually 1 amp is already big number. So but 1 amp for all the relays one. Relay also will use some milliamps one. Because this load, let's say using higher one, so I use 5 amp power supply. So if anything happen short to this, it only spoil my relay, not my output. Not my output. It only will spoil the relay. If let's say I'm not using this, the load straight away I put it here. Okay, and I'm using a bigger power supply, for example. Okay. So if anything happen to the load, let's say put it here, if the load is short, so it go and damage your output.
You mean the load is the relay?
No, I mean the load. If I'm not using relay lah, I use the load straight away put it here. So if the load, if anything happen, your instrument lah anything short, so it can damage your output. Yes. And maybe sometimes the particular output Y0 only can use. That one very common. Very common. I've done so many troubleshooting like that. Whenever I go, they say the motor not working. When we start, cannot work. And they say last time the motor output they can see, but now not on. Everything. Sometimes then I go and troubleshoot, then I can see the light on the PLC. But when I measure, there is no voltage. Because why? Because this PLC is a transistor output. Because it's what C32T, right? So it's a transistor output. Means inside that there is a built-in transistor, so which is running on very low amp. If some higher amp is go through, so it can burn the transistor. So when I go and measure, okay, no voltage. So I need to check any spare output or not. So let's say Y0 spoiled already. So I check any spare Y6. So I change the cable to Y6. In the program also I need to change it. Okay, good. Okay. Any question on this? you can go offline. Here can delete this. Okay. So X is set. Then I reset the motor, right? Okay. Let's say at the same time I want to use this project lah. Okay. So I want to use the timer to reset and on the motor 2, for example, right? Okay. Click here. You control down arrow. Yes. You put set Y1. Enter. Okay. Convert. Okay. So it means I start set. So once the motor on, after timer I reset the motor 1, set the motor 2. Then the motor 2 can run. Then for motor 2 you can do another timer. Okay? You try to do the same project that just now we do, but using set reset. Okay, but you test this one first, try to understand. Y1, Y2, right? So you see the input is same, right? So you can do like this, like a branch.
Or combine.
Yeah, combine, because all the input are same, right? So this one, the up also, the first one also.
So I can combine it at the first stage or after
Mean which one?
the reset.
You can put it here, put up there also can. Go up. Here itself also can. Control down. Okay, reset Y1. Okay. Then another control down. Reset Y2. Okay, go down. Second. Okay, because you're online, right? That's why you become red color, huh? Okay. Now convert. So you download the PLC. Because just now you do online edit, huh? Okay. So just put stop like this, okay? So this position is not an issue. It can be here or can be down there also.
So before we start, also we can put the reset.
Can, no problem. Because why? Here the timing is not very sensitive. Correct. Then, so not an issue. Since the time is sensitive, then only we choose where we want to put it. Okay, good. Any question here?
So far.
Okay, so we take a break. After the break, come and see some data register. Then we try to do a project. Okay? Okay. so much. I think for this PLC they have around 32,000. Okay. What is DT? So DT is data register, means it can store value. Okay. Like R means it can store 1 or 0. Okay. But DT means it can store 16 bit. 16 bit data. Okay. Like R is just 1 bit only. Okay. So why 16 bit? Right. Okay. Because you see our timer here, I need 16 bits. Because value, right? So 16 bit of data for timer. Okay. Okay. Now I'm using a constant number. It means the timer, I have a fixed number. Let's say this timer I want to change from my HMI. Right? I cannot change. Correct. Because why? Because the value is already fixed, that is K10. Right? So it's a 10 seconds. So if I'm using a D instead of using a constant, if I use a data register, means I can key in value in the data register. Okay, good. Now what we do? Okay, you give it a name, like for this timer 1 value, timer 2 value, timer 3 value. Now you change this. You double click here. Yes. Double click to K10. Is it offline mode? Yeah. D10. Change to D10. Can you change? You put at this position. Right? Click on this. Double click on this. Then you put the TM. Yes. TM. No, TM. Timer. Add the timer. Yes. TMY. Yeah. 0. Enter. Okay. D10. D10. Cannot change D10. Can D10. D, it become T, K. Or it become K. You click the DT here. Okay. DT is 0. Yes. Okay. Yes. Same thing for this. Okay. Now can download, convert first. Okay. Now you press start. Nothing on, right? Why? Because your timer don't have value. So what happens? Actually, when you start, it's on already, but timer no value, so it's off on the second motor. Second motor, so it's like 1, 2, 3, done, finish. Because of the timer value. Okay. So if I want to key in value, where I go? The default device monitor. So the IODs can close. Online. DT0. Okay, now you key in values.
Here.
Yep. So how many? 10, okay. You key and you need to enter. Okay. No, it's a Z. Yeah, it's a O. Okay. Yes. Okay. Then you monitor. Here. Yeah. Okay. Just now it's not monitor, that's why I cannot see the value here. Okay. Now you press start. Now can go. So just now it's a constant number, right? So if you want to change the value every time, you need to go to program, the K10 change to K12, K13, download again. Now I just go to the D area, just change the value at the D. So I mean I go to the data register, I just change the value here. So I don't need to download. So just change the value here, for example. So it becomes 20. Okay. So now what? I just then later I can put the timer, these values into my HMI. Yes. Okay. Okay. All right. That is the function of the DT actually. Data register. Okay. Any question until here?
So anything, if I want my user to key in, need to create data.
Yes, must use data register. Good. So anything that is push button must use the R. So that one tomorrow we will learn. Tomorrow or the third day we will learn on the HMI part. Okay. So okay. Now what we do? Okay, this one is safe aside. Now we do a project. Okay. This one is similar to the projects just now you do. The similar thing, we just need to additional some items. But before that, I will show you one thing. So whenever you do a project, right, you need a flow chart. Okay. So the flow chart is like this. So they have two symbols. One is the condition, one is the function. Okay, one is the condition and one is the function. Okay. Now, so condition means like your interlocks. Means okay, when I start, stop. Okay, if it is working, what I do? If it is on, okay, what I do? If it is off, what I do? Okay. So this is the function, or we can call like a result. Okay. So like an example, like just now we do one, right? Okay. When start PB lah, I put PB, so we can understand it's a push button. Okay. Then the output is motor 1 is on. Okay, motor 1 on. Okay. Then I have so I run a timer. Okay, T0, or just put timer lah. Timer 1. Okay, timer 1. 10 seconds. Then once the timer 1 is done, okay, once the timer 1 finish, motor 1 is off, motor 2 is on. Okay, then stop here lah. Finish. Then if I press stop, motor 1 and motor 2 both off lah. Okay, so this is the flowchart they give you. Okay, now from the flowchart I want to do a program. Okay, so how? Okay, start. So always these are the conditions. Means like it's on, off, or something. Okay, so let's say like this. Okay, start. PV. Okay, let's say I'm using a coil. Okay, so motor 1. That's all, right? Okay. So start motor on. Okay, then the motor need to off after the timer. Right. So until then the motor must be on. And this is my push button. So I latch. Because they don't give you, in the flowchart they won't give you they don't ask you to do latching. They just tell you on, off. Normally, because you do the flowcharts, you know, right? Okay. So when this one, when gas reach, this value, then I open the valve. Yeah, right. So if the valve is open, then I can measure on the pump, something, right? Okay. Similar. So in the flowchart, they just let you know, okay, when it's open, when it's closed. That's all. They won't give you whether I need to use a set reset or latch. So they won't give you. Okay. Then start on the. So at the same time, you see, start on the timer, right here. Okay. So the condition is the start. So at the same time on the timer lah. So timer TMY, right? This one. TMY0 K10 lah. Okay. Now we know that the timer, if I want to run the timer, this line must be always on. Correct? According to the flowchart, when I start on the motor, at the same time on the timer. According to flowchart. But here, so when I do this, when I follow this means input, output, something like that. So the start button cannot run the timer because it's a push button. Means I press, yes, the timer can start. But the moment I release, the timer becomes 0. Okay, so what I do? Motor 1. Yes. Why motor 1? Because when I start, at the same time the motor 1. So I can use the motor 1. Unless, let's say I have a sensor that is on the timer, then I can use the sensor to off. Okay, done. Then timer done, motor off. So timer done is what? The T0, right? Because that is a timer output. Okay. T0, motor 1 off already. Then the same timer need to on motor 2. So T0, motor 2. Okay. Now, do I need to latch the motor 2? Okay. No need. Why? Because after the timer, motor will off. So timer will reset. The timer will become 0 already. This E0 become after reach 10 seconds on. Then when motor off already, off. Correct. So I need to latch it. But sometimes when we see we cannot, when we according to this, when we write the program, sometimes we cannot imagine. Of course, this one we know already because it's a push button, so we know, okay, this one push button, the timer, the motor need to run, okay, I latch. But sometimes this one we cannot do. So what we do? No problem, just test it. If it is working, it's okay, no need. If it is not working, then I need to latch it. But you need to understand that the T0 is actually on, because we cannot see what sometimes. Because the T0 on, that's why your motor off. Correct? So you need to understand first. Because sometimes if you put like this, sometimes if you just watch this, right, sometimes you see that T0 didn't on. Because very fast, right? So you also confused. But how to make sure the T0 is working or not? How to know? That is, the motor is off already, it means the T0 is working. So that one no problem, that is the logic. Okay? I'm just showing you how to come up with the logic. Okay? Then, after test, then you know need to latch. Okay? That's all. Until here done. Okay? Now when I stop, motor 1 off. Okay? Now, so actually I can put reset also. Not set reset. This one I on. For output, I can reset. Use reset also. Okay? The reset is not necessary, but you set then only reset. Okay? But as a good practice for programming, if you're using coil, use the don't use the reset. If you're using set, then only use the reset. Okay? So stop. Okay, here need to stop. To off this. So to off this, here need to stop. Okay. So this is how we do it. Good idea. So just now this is the way you do lah. But just now how you do, because you follow the first line. First line, okay, you know already. Okay. This is how it works. Only the addressing is different. So you just use the same way. Just play with the address and go ready. But this is how you use a flowchart to come up with the program. So first you do this test. Then you add a timer, you test. Then you add this one, you test. You add this one, you test. So every time you test it. That's how you can learn PLC programming. So because you know why? Why you need to know how to do program. Then only you can read other people's program. So when you read the program, then you can understand why they put why for the timer, why they put DT. This timer they put DT. Another timer they use the constant number K10. So you can understand why. Because this one K10 is a fixed. So always is a 10 second only. You cannot change. On top the other timer they use a data register. Because why? It can change. So maybe it can change from the HMI, or maybe it can change from another PLC. Because PLC to PLC can communicate. They use the link code, right? So there's so many possibilities to change. Okay? Any question here? Okay. So far, okay. Am I too fast? Alright. So we already, of course, normally close all the program we have. Okay, then timer, right? Then set. Now this project. Do this project. I think in the manual also I think I have the project. So it's a tank project. To mixing lah, okay? Mix. Actually, I always use this as the first project because to be familiar. So I want to know whether they are familiar. The next project maybe I can give you similar to your system. Maybe on the third day. So we can discuss about how the system works, right? Then we can come up with a simple project. So yours is like you have an input bar, output bar, right? Everything like something like that. So you can create some program according to your system. So So you get the idea how they do this project. Okay. Then, so this one is they have a mixer, motor, pump. Then here I have one A. Here I have one B. Okay. Then normally tank will have a level transmitter, which is analog. Okay, level transmitter, which is analog. Okay. Now, but we haven't learned analog yet. So what I do, I put like a float switch. Float switch like this, right? It's just a normally, like not normally open or normally closed switch. Depend lah. Okay. But we use normally open because because we don't have an actual tank, right? So we can use the push button and all that. So there's the switch 1, switch 2, right? The selector you can use as a low one as a low level, one as a high level. Okay, good. Now, so how it works? Okay, this machine have a, of course, like any project you do, I mean when you do yourself, always put start stop button. So it will be easier to do. Then, if you want to do projects, do like a few I/O first. Do like a few I/O, like maximum. Your first project lah, maximum you take 10 input, 10 output. You do that first. So when you finish that, when it's running, I'm not talking about actual machine. Do your own simple one. Okay, you just imagine. The thing is, you need to first thing is you come up with the flow chart first, process flow first. Then you do the project because when you want to test, you test according to the process flow. At the same time, you need to know how the process works. Okay, because you're from chemical side, right? So you know more on the process side. So what I mean is, okay, let's say this tanker. So when I press start, let's say the valve A is on, for example. So when I press start, the valve A is on, then it start to fill, right? Okay, so it will reach the low level. Now you don't have the actual machine, right? So when you do simulation, you don't have actual machine. So you need to know when to on the low level. Okay, so this one no timing, right? So anytime can on. So I just on. Okay. Then let's say I want to stop exactly here at this position. Okay, so let's say I put a timer. So when I press start, valve A on, I wait for a few seconds and I energize the low level switch. So here I am using a switch. If you are using simulation, you just on only. For start button, you put on and off. So if low level, just on only. Okay. Then go here. Then once I reach 10 seconds, after 10 seconds, valve A off, valve B on. Okay. Then valve B start to fill until the high level. Okay. So just imagine. Okay. Now valve A off already, valve B on. So you know, okay, already reached the high level. Okay. You on the high level. So when you on the high level, valve B off, mixer on. 10 seconds. Now mixer running. Okay. Mixer running for 10 seconds. Then mixer running for 10 seconds. After 10 seconds, mixer off, pump is on. Okay. Pump is on. Now when the pump on, means the level is dropping a bit or decreasing, right? Okay. So you need to know, you first need to off the high level. After a few seconds, then you off the low level. Because we don't have the actual machine. Then so you need to know. So when you do flow chart like this, when you do simulation, so you need to know all this. So when dropping, okay, you know which sensor will react. So the high level will off first. Then after a few seconds, the low level will off. Then if both the sensor off already, then I off the pump. Something like that. So when you do flow chart also, you create that way. Then you do program. Then when you do testing, you test the same way. So then only you can know, because you don't have the system. If you have system also, you need to do a proper program at that also. Okay, if no means right, it can damage the system. If you're working, I mean actual system. Okay. Let's say because this is a tank, let's say you forget to put the high level switch. When the valve B is running, you forget to put the high level switch. What happened? Off. So must be everything. I mean normally when I do work, when I do programming, I mean when I do commissioning, right? Do program and when I do commissioning, normally I will assign one of the guy there, or if I bring my technician, let's say I have a technician lah, so I bring him for user system. I always ask him to stay at user system. So here, so what happened before I do any project, all the output I make sure when this system all the output cut off. I make sure that first. Okay. Then only that's the main thing first. Then only I do the flow everything. So when I do testing, okay, if I see if let's say overflow or something, the sensor is not doing this. Okay, let's say example this one. So you know already up to this level the sensor is supposed to on, but now not on. Okay, you go stop, then go and check the sensor. Why not on? And before that, you must check all the sensors before you. Normally, this is how the system works. Means, okay, when you buy the system, they come and fix the panel, everything, right? Panel, and this is your machine. They do the wiring, everything, right? Then only they come and do the download the program. Program is already done already. Okay, but when the panel come with a zero program. Okay, then they will test all the wiring, everything, check all the input output, make sure all the input output is correct according to your IO list. The same list you give to the programmer also. Everything same, you cross check everything. Then only they will download the program itself. Then only they will test one by one. So you press that, level increase, all that. That's what they do during the commissioning time. Right? Okay. Previously, where you work? Oh, sorry. How long?
More than 2 years.
More than 2 years now. Which department?
I'm under R&D department, but I work under project lah.
Project lah.
We build the polymer resin plant.
Okay.
Pilot scale plant.
Oh. Okay. So then you should know all this.
Something similar like this, mixing the monomers become polymer. We have so many things.
Yeah, actually that's why normally I use this time function because most of the company they have this. Some of course sometimes semiconductor company, most of the companies, chemical companies, food industry, chemical, pharmaceutical company, all that sure they have something like this. That's why. So it's simple. Actually, this project actually similar to the program just now you do. See, just now you do. I start one output, one motor. After timer, the first motor off, second motor. After timer, second motor off, third motor. Same here. I start valve A first, but they have 2 additional inputs. So I start valve A first. Okay. Wait for the low level, then timer. After timer, valve A off, valve B on. Then valve B until high level. After that, valve B off, mixer on. Mixer run. After that, mixer off, pump. Something sequence. Okay. Alright. So when you have this, the first thing is IO list. Okay. So input, output. That is the most important thing. Okay. So according to our wiring here, so the start and stop, we can use the X0, X1, right? Yeah. For the low level and the high level, we can use the X3, X4. Because the third one is a push button. So we can't leave it on, right? So the third one we don't use. So the first 2 push button and the two selector switch. Okay? Output, okay, no problem. But when you do simulation, right? Or when you're testing something like a training kit like this, output is not the issue. But actual, then you need to follow, right? So when you manage the project, you involve more on what in which area you involve more?
Because I'm managing it's under our team project. So
Okay.
I'm managing all over the project.
Overall the project.
Couple of each department handling one. Wiring is they got
Yeah,
other
of
department.
course. So you handle the
Project.
whole project lah. Okay. So of course many projects here.
So basically, I'm more to the process and handling the departments.
Oh, okay. You know, any project you do also same. You cannot do it unless it's a small project. So that's why normally I take only small projects. Because I do the programming, I do the wiring. The last time I have one guy, he worked here for 1 year plus then he left. So that's why I have more like small projects. Let's say I don't take more than like 20 items. Because you need to build the panel, or sometimes I tell them, okay, I cannot build the panel. I give to my partner. So ask him to give the panel, or maybe if some work, additional work like do some mechanical work, all that, then I give it to him. Then I say, I only do work. The same thing I'm now I'm doing a project for India. Yes. So they have a chamber, so they release methane gas, CO2 gas to harden. They have a brick. So to harden the brick, they want to use the CO2. Okay, so what happened is they want to control the CO2 temperature, pressure, everything, and control the solenoid to release the CO2. So measure CO2, drop, okay, release. If it is dropped, release something like that. Okay. So I do the pen. Pen very small, just make it small panels. Then we buy the sensor. So what happened? The sensor need to fix, right? So I asked the guy, another company lah. Any project they have, I have, then I give to them for manpower supply lah. So they come and fix for me the sensors and got to do everything. Then they supply, then they install all the sensors. Then I ask them to put the wire, they put me. Then I take the cable, then I put in my panel. Then I do the program. So that one is okay, can do. But if you do like a big system, I mean a bigger machine, of course, programmer is one person. Not actually one person also, one team, yes. They will have a few guys. Because not all, if you see your programmer, but your program, I'm not sure lah. But sometimes programming is not done by one person, like a team. So one guy is more for, he can do the main part. The other guy will do the other parts and everything. Yes.
Okay.
Okay.
Can you? I don't want the date because this one is claiming for purpose now. If you want to put the date,
I just sign and job. Okay, I'll give you a quick one. The official receipt you want me to print? Send me the official receipt.
Yeah.
Oh, okay.
Okay. So it's not done by one person normally. Okay, it will be like a team. So because one guy is more good at the process, the flow. One guy may be good at analog functions. One guy is good at HMI. So they will segregate their job. Then they will do their own job, right? This guy do the program, this guy do the HMI. I think finally they will compile everything. Same thing for your electrical team also. So you come up with the process flow, and then you give to them. They come up with the wiring diagram to design. And one guy will do the design, another guy will need another few guys, they come up with the panel, do the panel wiring and everything. Then mechanical design, okay, let's say the time, okay. Another group they will do the mechanical design, everything, come and fix everything and all that. So that's how it works like that. Okay. So you move on the management and the process. Okay. So you, I mean, if the management then is you will follow the FTS, FAT, SAT, the factory accepted test.
Oh yeah.
The test all you do, right? The pattern test and everything. Okay. Now, so once we done this one, now the flowchart. We have to make it a simple flowchart. Okay. So when I start, okay, I put PB. You understand what's happening? The valve A on. That's all. Finish. Okay. Then when low level is on, because I put for low level I put on because when it's on it's a different, need to do some functions. When it's off, need to do some functions. Okay. This is a push button, so I don't need to do that on off. Okay. So I need to energize a timer. Just put timer VA, valve A. Okay. 10 seconds. Then once the timer VA done, valve A off, right? So valve A off, then valve B on. Okay, finish. So start to fill until high level. Now when high level is on, VB off, then mixer on, right? Mixer on. So at the same time timer on, right? So I put timer, mixer, 10 seconds. So when timer, mixer is done, I need to off the mixer first, right? Mixer off. Pump is on. Then pump start to work. Then when high level and low level both off already, one by one, right? Then the pump off. Okay, that's all finished. One cycle lah. Later once we done everything, then maybe continue. Maybe we can do the continuous. Okay. Then when I stop, valve A, valve B, mixer, drain off. Okay. So when you want to do, you don't need to do the whole thing then test. No, difficult. Okay, because if you do whole thing and test, if halfway any problem here, are very difficult to solve the issue. If you don't know where is the mistake, where is the problem, sometimes you give up, you delete everything. But that's what normally I do. Sometimes you do program, you give up means you delete everything. So the best way is start valve A on, right? You can stop. So every time one output on off, you stop there. So maybe here, then at the same time you can add the stop button for valve A. Then the low level add on, timer, after the timer valve A off. Okay. Do until here, okay, you test from here. Then after the timer valve B on, when high level on, valve B on. Then mixer on, timer, mixer off. So it's easier to test the program. Okay, good. Try this. The receipt, the payment receipt, what date on? Receipt date, 15 September, payment date.
date I put as 15 September, right? Okay, this one also you want me to put the date? Okay, so okay.
start. Okay. Timer. Reset set of a high level. Reset of a setting server. Reset on timer. Reset set on. Okay, so you use set and set lah, right? Okay. Okay, we start. Monitor first, so you can see here. Okay, you click here first. No, online. Yes. Okay, low level on. On, okay, high level on. Running. Then on, okay, high level off. Low level. Alright. And if I stop, all off lah, right? Okay, good. Save. Okay. Alright. Any question until here? So far.
If I say instead of set, I use the coil. Can also. When I want to close the
Wall, right? You put normally close.
normally close at the same run.
Yes. So means coil means it's just because coil means it getting the signal from back from the line. Okay, so of course you need to do latching or no need to do latching, it's depend lah, right? Okay. So if you want to off the coil, of course need to cut off the line. So is it normally close to cut off, normally open to cut off? It depend on the situation. Same like this. You see here. You see, you use this normally open high level to reset the valve P. Right? Go down. You use the normally close high level to reset the pump. Because two different situations, right? Because here, when I on, I reset the valve P. Here is when I off, I reset the pump. So different. Same thing. When you're using coil also, it's not always, because sometimes participating normally close is always the cut off. No, it's depend on situation. So if you want to cut off, you want to use normally close, normally close. You want to use normally open, then you use normally open. Okay, good. Any question so far? How you feel? First day. But are you familiar with the software? Have you used before the software?
No, after I came to this company, I tried to see some videos and try to use.
Try to use the software. Okay. But I see you are familiar with the software. Because the most important thing is familiar with the software is the important. Then the rest is addressing. Actually, when you want to do programming, okay, software, addressing, then software addressing, then what else? The data types, then the instruction, some instruction, that is important. Okay, good. Alright, so if no question, whenever you're done, just save. Then you close, then you can continue tomorrow.
kiri mata.